Hi, everybody.
Nano assembled capsules, and I'm very much interested to attend this conference and present my paper. And I thank the organizing committee for giving me this golden opportunity, and especially the Sir Dinaharan, who took a lot of steps and initiatives, and he motivated me. So I thank all the organizing committees of this conference for giving me the wonderful opportunity. Thank you.
Hello everyone, I am Dr. Arsha Shakir from Bangalore, India. I am an associate professor and a dentist by profession. I have done my master's in pediatric dentistry, that is dentistry for children. Currently, I am also a research scholar in the field of nanodentistry under the guidance of Dr. Pushpalatama. I am doing my PhD in Ramaya University of Applied Sciences. Today, I will be giving a short invited lecture on applications of nanotechnology for enhanced antibacterial activity in composite dental restorations, a review in this literature. I would like to thank the organizing team of this conference for providing me a beautiful platform and giving me an opportunity to present my paper in my area of interest. Looking forward to you for this conference. Thank you.
And I'm the director of Angkasa Kowaris Plastic Sandaran Plant. Our company is a recycling company, and we have started up the company around 4 years ago. But prior to that, I have 25 years of experience in the area of plastic recycling. Right now, our company main processing is doing recycling of plastic waste. The company, which is short form, the acronym is ANCOP, Angkasa Kowaris Plastic Sandaran Berhad. We have full compliance from the government, from the ISO 14001. We have a compliance in the Department of Environment. We have compliance with the municipal government bodies of Malaysian government. Our main job is not only to make money, but obviously it's part of it. But then it's also to help the country to develop to a state where we are able to bring in processed waste material to reduce the waste that is dumped in even in the area of landfill. We are extracting plastic waste, we convert it into usable plastic. We hope that this program will work well. At the same time, what we have been doing is work with the various colleges and universities in Malaysia to bring them the knowledge and equip them with a better knowledge of recycling. And in time to come, we hope in the next few years with this program and the courses run by our company, students will be well trained and be more cautious about our environment. We hope that the government of Malaysia will continue to support us on the long term, and the staff in Bangkok, they are all very hardworking, and we feel that we still have a long way to go to achieve our goal. We appreciate that whoever that is looking into this video, and
Ultrasound therapy is a treatment modality used to treat painful soft tissue and muscle strain conditions. Multiple international studies have shown that ultrasound systems are regularly inaccurate, and operators are unaware if their system is behaving as expected. This is due to the invisible and inaudible nature of ultrasound waves, coupled with the fact that patients experience limited sensation during the treatment. There is currently no straightforward method for clinicians to check their ultrasound system performance in-house. Through Enterprise Ireland's Commercialisation Fund programme and supported by TU Dublin Hothouse, scientists in the Centre for Industrial and Engineering Optics have developed a unique technology to overcome this issue. The prototype consists of a hologram fabricated in a patented pressure-sensitive material. The prototype hologram changes colour from red to green in response to incident ultrasound waves. This allows for a fast, easy check that the ultrasound system is performing as expected. How it works. The hologram is first placed in the specially developed viewing unit. It is initially a uniform red colour. Either ultrasound gel or water can be used as a coupling medium. The ultrasound transducer face is then placed on the hologram surface. The ultrasound unit is then switched on, and the power density, duty cycle, and frequency are set to predetermined values. The exposure or treatment time is set for between 2 and 3 minutes. The hologram is then cleaned and repositioned in the specially developed viewing unit. If the therapeutic ultrasound system is functioning as expected, an area of green color will be visible on the hologram surface. A record of the obtained green color can be captured via a simple photograph or quantified using a color finder app available for all smartphones. The size of the area can also be measured. If the system is functioning correctly, this size will remain unchanged during repeat weekly measurements. A change in the size of the area on the hologram surface, or no change at all, indicates that the output of the ultrasound system has altered unexpectedly. In this instance, the system should be returned to the manufacturer for servicing. This straightforward test can be performed quickly and easily every week. Each hologram is single-use, and the observed color change is permanent. Therefore, each tested hologram can be stored as a record of in-house quality control procedures. Contact the IEO research team using the address on screen for more information.
The Ankara University Faculty of Pharmacy was founded on the 16th of December 1960, and education was introduced in the academic year of 1961 and 1962. It was the second institution introducing a program in pharmacy in Turkey. However, Ankara University Faculty of Pharmacy was the first faculty of pharmacy founded in Turkey. The faculty was managed by a core team with limited resources in the founding and early years. In 1970, 10 years after its founding, Ankara University Faculty of Pharmacy has made remarkable developments in every area of pharmaceutical science. Today, Ankara University Faculty of Pharmacy consists of 23,000 square meters of closed area. Our faculty has 3 lecture halls with 160 seats each and 12 classrooms with various sizes. To qualify as a pharmacist, the education takes a minimum of 5 years, and the students must be successful in lab courses of analytical chemistry, biochemistry, pharmaceutical microbiology, pharmacognosy, pharmaceutical botany, pharmaceutical chemistry, pharmaceutical technology, and pharmaceutical toxology. Additionally, our faculty have 2 conference halls and 1 meeting room with 400, 260 seats respectively. All meeting rooms are in the service of the students. The recently established Pharmacy Museum, Devices and Chemicals Museum are located in the main building of the faculty. Research laboratories of the departments Herbarium, Administrative Departments, and the Deanery are the other divisions of our faculty. The teaching staff of our faculty consists of 56 professors, 13 associate professors, 12 assistant professors, and 49 research assistants. The administrative staff consists of 95 officers. The total number of enrolled students at our
Dr. Binita, are you there?
Yes, I'm here.
Okay, madam. We can start around 5 minutes from now. Is it possible for you, ma'am?
Yeah, no problem.
Okay, we start 9:10 Malaysian time. 5 minutes. Maybe madam can prepare for your slide, everything, and share first. Then we can start because our first presenter is unable to join from Bangladeshi. So we start from you, ma'am. You are the first presenter. Is it okay?
Okay. So the PowerPoint presentation I can do from my desktop. Is it possible?
Yeah. You may share, ma'am. You may share. You can see there's a few buttons. Share button. Just click the share button. Then you can prepare first. So from 5 minutes from now, we can start. I will inform you, ma'am.
Okay. No problem in that. Thank you.
Okay. Are you ready, ma'am?
Yes, I'm ready.
Okay, ma'am. All right. A very good morning from Malaysia. I'm Tinagar Narayanan, conference chairman. Today I will be coordinate for all number 2. For the first presenter, our Dr. Vinita Dutta from India. She is an assistant professor from the Department of Chemistry, Banarwal Balotia College, Asnasol, West Bengal, India. She's going to talk about a review on recent progresses in fungi-based fabrication of nanoparticles. Ma'am, you have 20 minutes for your presentation. Is including 5 minutes for question and answer and discussion, ma'am. So you may start your presentation.
Okay, sir. Share. Is it visible, sir? My presentation?
Yeah, ma'am, it's visible. Please remote to for the slideshow mode, ma'am.
Yeah.
Yeah, okay. You may start now, ma'am.
Thank you, sir. And it's a very good morning from India. And today I'm just going to talk about a review on recent progresses in fungi-based fabrication of nanoparticle. So, talking about fungi, it's a well-known decomposer and recycler of nutrient in the environment, and being it's a eukaryotic, it can be monocellular like yeast or multicellular like the other many pictures I've given in the left side. And they do not have true roots or stems or leaves. They mainly have that mycelium and the fruiting body part. That's actually the spores producing structure for the reproduction. And some fungi are edible while the others are poisonous. And here the fungal cell that as a simple diagram has been given, which will be we are going to discuss a little bit for that the cell membrane on the fungal cell, it's a kind of, it has the protein or beta glucan and the chitin structure which are actually capable to aid the nanoparticle formation. And nanoparticle can be formed inside or outside the cell. So the cell membrane structure as well as its cytoplasmic structure is also important and contributing part. So the fungi, these are not a new name to us, because without the baker's yeast, we'll not be able to produce the daily breads that we are baking. And besides that, also it has the fungi has come into as many of others in our market, like the biological insecticides. It's actually a stable and very good for organic farming. So they target their damaging insects or animal pathogens very good. So there are these kinds of insecticides based on fungi in the market, or in the farming, that mycorrhizal fungus. You can see that if you search for that, you can see the packets that are used. So they do that micellar structure. This micellar structure actually go around the roots, and it will ensure more nutrients goes to the plants or the crops. And all the food, I have already told you that the yeast already it is producing the breads for us. And besides that, the true foods, they are exotic food delicacies besides the oyster mushroom or button mushroom that are a common name in our plate. And as medicine, it also they have shown that they sometimes they are of commercial importance, that they can inhibit the growth of bacteria and so on. And we know that the penicillium, it's a common name for the antibacterial. So now, whenever we are connecting it to another field of science, that is a nanotechnology, the nanotechnology deals with a very small scale of particles. So nanotechnology is not simply dealing with that 1 to 100 nanometer of particle. It's also rather working that in that nanoscale, the material behaves something different, and as their surface area got enhanced drastically, so this enables the scientists to utilize their unique physical, chemical, or mechanical, or optical properties, so that we can utilize it in many scale, from biosensing to medicine to imaging, or water treatment, or antioxidatives, or antimicrobial, food packaging, agriculture, textile, inflammatory drugs, or drug carriers. So there are many applications in nanotechnology, and it's a common name for us. So whenever we are connecting it to the fungi-based nanoparticles, so why we need fungi to do the nanotechnology? So going to the next slide, we can see that the synthesis of nanoparticle, it can be chemical synthesis, or a physical method, or that biological synthesis. So coming to the chemical synthesis, it is actually the till now the most used technology for nanoparticle synthesis. And the physical method, mainly they do the ablation part, or they are just milling or crushing that bigger part to the nanoparticle. So it's a physical method, and it involves very high power instruments, or the energy consumption in the physical method is very high. In comparison to these two methods, they have some they have some drawbacks. Like the physical method, it needs a high voltage equipment for doing the laser ablation part, or doing the milling part to get the nanoparticle. Whereas chemical synthesis, it involves an abundant amount of organic solvents, which are not green to us, not green to environment. And whenever we are doing in the industrial scale in through chemical synthesis, so the use of that organic solvents, they are actually, we cannot just omit it. And now when you are discussing the third part, that the biological synthesis, it's a kind of emerging part for nearly 25 years or 20 years mainly. It's just being a matter of discussion. So it's a biological synthesis, it's a green synthesis, and we can use the plant body parts like leaves, seeds, flowers, roots, or barks, stems, etc. of a particular plant, or we can use the microorganisms like bacteria, fungi, or we can go for the algae, or we can go for the molecular parts. We can just extract the enzymes or biomolecules, and then we are going to do that. So why we are going for the biological synthesis? It is actually the greener alternative. It does not include the harmful organic solvents. We can omit this part, this organic solvent part, and we can just have a very rapid synthesis for a nanoparticle in a greener way, and then it is also stabilized by that biomolecules also. So we don't need to give additional some harsh reducing agent or some capping agent for stabilizing the particles. So they work in both ways, and the people are exploring this field, and they are going to now the picture of this research part of this research field is just revealing with time. So the nanoparticle synthesis, it can be done from top to bottom strategy or bottom up strategy. Just in the earlier slide, we have talked about the physical method. So physical method is meaning the bigger particle size, we are reducing it to smaller particle size. So it will be a top-down method. From top, we are going to smaller size. Whereas the bottom strategy, we generally start with the solutions, in which they will be in the molecular states or atomic states, from where from the dissolved state, they will just accumulate or agglomerate into some nanoparticle formations. So the fungi-based that mechanism, it actually is a very good example for bottom-up strategy. We start from a solution or a precursor solution like a silver nitrate for silver nanoparticle, or gold, or some other kind of metals. We are dissolving it into suitable mediums, and then we are just giving the biological samples. So talking into some brief mechanism, so I got the help of this beautiful diagram. So the mechanism of biosynthesis of nanoparticles, it involves just roughly you can say it can be distributed into 3 steps: extracellular synthesis or surface synthesis and stabilization. So we are not talking about the internal synthesis right now. So whenever you are just going for the surface synthesis, you can see from outside the cell also, it can get the electron and get reduced by the biomolecules, and this particle can agglomerate, and this M plus goes to that M0 state, and this eventually is being kept by or stabilized by them by that particles like the bigger particle chains like proteins or peptides or bio macromolecules. They just wrap around that molecule, that nanoparticle, and they stabilize that part. So it can be done in the outside of the cell, totally extracellular, or it can just bind to the surface of the cell wall. So both mechanism is possible. And so the reaction can occur the inside the cell also and outside the cell also. So it is expected that whenever the nanoparticle is forming inside the cell, the initial size of the nanoparticle, you are expecting it to be smaller. But there is another thing we have to remember, that whenever it is being inside the cell, we have to take it out from the cell. So there are some methods involved to extract it from the cell. So this method may or may not be green, or this method may alter the yield, the overall yield or the final yield of the nanoparticle synthesis. And here you can see that the fungi actually catalyzes or that nanoparticle formation, not only reducing or giving stabilizing agents, it is also just giving a it's catalyzing the reaction also by their enzyme production. Fungi are very rich in enzymes. So whenever we are going for extracellular or intracellular, this is also kind of similar photo. So we can see that intracellular synthesis of nanoparticle has been gone. They have shown it like that. And in the lower structure, the in the surface also, we can see that this green color formation, this is the attached with the protein, binder protein with that cell wall, and it is producing that nanoparticle, or we can just attached with the cell wall and have the reaction done. So the extracellular formation are most likely to bind the cell surface through the extracellular enzymes, or intracellular synthesis. Here it actually informs the transport and biomolecules of ions inside the cells. So I've already told that part, that inside the cell, we expect that the nanoparticle forms, it will be a little bit comparatively smaller in size. However, the extracellular part, the method will be easy and rapid. So this is a good paper. It is a typical example of some fungi-based nanoparticle. The outline, you can just see the methods they have done. So there we can exploit that fungi medium, the cultural medium, in various ways to form the particle. So if we go for the extracellular fluid, we can just have that infection from plants, or we can grow in the plates or some cultural medium like agar medium or so. So afterwards, whenever we are we have cultured it, we can just get centrifuged and get the extracellular fluid, and then we just add it the precursor solution to get the nanoparticles. Otherwise, we can just get the washed biomass also, and we can suspend. And this part is important because we have to do without as cautiously to have some contamination-free environment. Because after washing the biomass very thoroughly, you have to transfer it to some buffer solution, and then you have to centrifuge, and then you have to add the precursor solution to get the nanoparticles. Or you can just disrupt the cell. You can just take it out, disrupt the cell composition, and then you can just add whatever the biological molecules after the cell disruption is just goes out of that cell, and then you are just putting that precursor solution, and it is producing some nanoparticles there. So we can use in various ways the supernatant or the intracellular components, or that extracellular ways. These all methods are kind of established, and people can adopt their ways or get their nanoparticle synthesis done following the suitable method. So speaking of some examples, we can just see that some gold nanoparticle, you can see that the interesting part of this paper is they have changed some parameters like the amount of the precursor solution, or the control of pH, or the reaction time. And by slightly changing the parameters, they got the very beautiful and very distinct shapes of the gold nanoparticles, like the triangle, hexagon, pentagon, or that triangular nanoplates, or hexagonal nanoplates, or star-shaped nanoplates. So they have just changed something. Just you can just see, for example, that whenever they are having that 1000 milligram per liter of gold solution they have used, and they have just done it at some slightly alkaline medium and doing it for 10 hours. So they are getting the triangles. And whenever they are having more concentration in gold and having the pH in the mild acidic region, mild to little bit harsh acidic region, they are getting hexagons. Or whenever they are longer time they are using, they can have the longer nanoparticles also. Or they can go from the switch to pH 6 to 8, they can make a change for that, and then they can arrive with the star-shaped nanoparticles. So you can see that whenever you are switching or tuning the experimental properties, you can just have your desired product also. So this is another example. They have used some 4 fungi strains, but here I have shown just 2. That 2 is enough for that. So they have used 2 different mediums. So one medium is that potato dextrose medium. It will have some natural kind of components like glucose, amino acids, or proteins. Or that suspect dox medium. This is a kind of synthetic medium. And it is for a carbon containing thing, it has the glucose, which is the reducing agent. Otherwise, it's a synthetic medium. So whenever they are comparing with that 2 synthetic medium and that natural medium, they have seen that in the natural PDB medium, the nanoparticle synthesis is way better, because it's a growing thing, no? That fungi. So it will take easily from a natural medium, the food source, and grow in that medium very easily. In comparison to the synthetic medium. So that actually affects the nanoparticle formation. So they have shown that whenever they are going to the synthetic medium, that quality of the nanoparticle is not good, or sometimes it's just pivoting out. Because, and whenever you are comparing with the extracellular and intracellular ways, they have done both. You can see that the left side is the extracellular and the right side is the intracellular way. Whenever they are comparing these 2 steps, they are seeing that whenever the intracellular way, so they are forming the intracellular way, the formation of the structure is okay. But whenever you are extracting into the water medium from that, it is not that much stable after 20 hours. Whenever the totally extracellular extract they have done, so these are actually quite stable, and their total nanoparticle structure, it is smaller, it are stable and well dispersed, and they're having the size nearly 8 nanometer. So from this paper also we can just use that, we can just tune the nanoparticle formation by using the medium, or we can just select that what we want, extracellular or intracellular. And the fungi mediated synthesis of silver nanoparticle, we have many examples. And so I've just shown this from one paper from 2020. And it is showing, you can just see the frequency of the silver nanoparticle, their studies. So many people who are doing that fungi mediated nanosynthesis, so a major portion of them, their studies include silver nanoparticle formation, and extensive study has already been done, because silver is a very good choice and easy to form, very rapid reaction from silver nitrate, and you can have various forms. You can just spherical to cubical to star shaped to many hexagonal. So many other shapes are formed, and mainly they are attractive because of their antioxidant and antibacterial properties. So people are just using their bacterial strains, and they are seeing the properties with that that biofabricated silver nanoparticles, and they just always gives some good amount of resistance towards bacterial growth. So there are some typical examples like that. The white rot fungus, it was just used for using the silver nanoparticle, and it has been shown that it's a very stable solution of 10 to 14 nanometer solution, and it has shown good and strong activity, bio antibacterial activity towards very gram negative or positive bacteria. So and also going to some smaller size, the second paper from colloidal surface. So they have used some other bacteria, some other fungi, and they have also been successful towards getting the antibacterial properties, and also they have shown that it was observed that the antibacterial activities of the other medicines like ampicillin or erythromycin or some other drugs, they are also significantly enhanced in the presence of this kind of nanoparticles. So this is a kind of good go. So going to the just a single celled molecule, that yeast, it has some advantage, because we can use the Baker's yeast. We know its structure, we know it's very cheap to achieve, or we need not to go to any forest to collect its original species also. So it can be just purchased from the market. It's easy, it's cheap, and you can just use to produce beautiful nanostructures like that. This candida yeast, it has been used for getting the circular nanoparticles of 20 to 80 nanometer of silver nanoparticle, and they have shown antibacterial strain against pathogen strains. And you can just see that right side, this paper, they have been very sure about the mechanism part of the silver nanoparticle formation. It has been beautifully done, this paper. So they are taking that this silver nitrate, and it has been reduced by the nitrate reductase, and you can see that from Ag plus, it is that nitrate part has been removed by the nitrate reductase, and we are getting the Ag silver nanoparticle. And this is after doing the growth. It is also kind of showing the stabilization with proper capping agents. So by producing this waste, and for in their method, they have produced nearly 5 nanometer of pardon per unit. It's written wrong. So the nearly 5 nanometer of silver particle was found to be stable without any particle aggregation for months. So and they have already explained the mechanism very beautifully, very pictorially, easy to understand, and they have already been successful to have the stabilization part also, because it's so small, 5 nanometer. In the left hand side, there are some pictures, beautiful pictures of some other fungi that has been used, frequently used, mostly for silver and gold nanoparticles, and also for the other metal oxide particles also. So coming to the other metal or metal oxide particle, you can just see silver gold alloy has been used for producing, and these papers are mostly recent. So they have also, this alloy also shown significant antibacterial, antifungal, and antioxidant properties. Whenever going for selenium, selenium was also used and for antimicrobial and also anti-cancer potential towards colon, skin, and lung cancer. And they have shown in the study that no cytotoxic effect was observed against the normal cell. There are examples for platinum or zinc or magnesium or titanium, and you can see that zinc oxide are in cosmetic chemistry. They are they have a huge application, like they heals the skin, so they already have their inherent kind of protecting or healing properties, chemical properties, and also they are very excellent antimicrobial agents as a chemical. So whenever you are producing it as a green nanoparticle by fungi, so you can just see that nanorods are producing beautifully, and it can be used against the bacteria. Can go for the other nanoparticle like zinc sulfide and gadolinium. This is polycrystalline in nature, and you can see this is a very good for biosensing activities. This is just a 2019 paper, and they have shown that the fluorescence intensity of the biogenic nanoparticle Zn is going to increase whenever we are adding the gadolinium. Going to the magnetic nanoparticle is very good for the therapeutic purposes because it hits the target very beautifully. So iron oxide can be produced, magnetite can be produced, these nanoparticles, and they have potential ability in the different fields of like medicine, industry, and wastewater treatment. Titanium dioxide, that industries in worldwide, they produce in kilos the nanoparticles. So here also people have used fungi for producing this. This cannot compete that industry level production by chemically the titanium dioxide or its that's need the industry, that we can say. So this is not a very used method for titanium dioxide nanoparticle formation by fungi, but however this study shows a very good and novel antibacterial material, and they have got spherical or oval shaped nanoparticle mainly. The other metal oxides like magnesium oxide, copper oxide, cobalt oxide, or nickel oxide, they have also there are reports that they have formed by that fungi-based nanoparticles. And I just want to go for the cobalt oxide in the last one, that photostability of this nanoparticle shows that they are stable up to 45 days, and they are ideally suited for the microelectronic applications, the cobalt oxide. Wherever you go for the little higher, the magnesium oxide, it has a beautiful application. They have used it they have produced it through fungi, and then they injected it to the wheat leaf, and they have shown that there is a boost of energy and enzyme activities in the things. So the stems are just longer, or roots are longer. They are going to deeper, and they are just taking significantly improved mobilization of nutrients by the plants. And they have shown that the crop harvest also improved between 38.7 to 63.2%. So this is a very promising aspect of this kind of magnesium oxide, or this green biogenic nanoparticle formation. This is a success, you can say. And also we have already talked about the biological activities, and here it's a glimpse or just taken into one slide, that the cobalt, they are extraordinary ability to transform the radioactive heat influx is used for the thermal energy, or it is used for the optoelectronic. We have already shown that the example, they are suitable for the microelectronic applications. Or silver nanoparticle, I have already told that they are antibacterials established for biomedical application, and whenever we are going for the green synthesis, it is also good for us. And whenever the gold nanoparticles, you can see whenever that the structures are being shown, the most beautiful structures of nanoparticle, you can see that gold nanoparticles are quite major in that. They form very beautiful, and their angles are sharp for triangular, hexagonal, or star-shaped nanoparticles, and they have that unique plasmonic features. So surface plasmon analysis or going for the biosensing activities, sensing activities of biomolecules, they are very good in that. Also, they have their applications in optics or electronics or catalysis or biomedicine. So. And zinc, already the thermal, they have environmental applications, they have biosensor application, thermal or optical properties. Or iron, you can see paramagnetic iron oxide, visual application in medical diagnostics. So whenever we are producing this by the green method, they are getting found that these nanoparticles can be used, and their formation or fabrication that can be tuned to the industrial level with some suitable minds. So people have shown their abilities, and people have used them after producing that. Yes, they are capable to do all these kind of properties for which are very beneficial for our mankind. So in the talk, we just come to the conclusion that microorganisms are quite capable to give our some production of nanoparticles, and fungi that it actually secretes very high quality of proteins, enzymes, and they takes part in the nanoparticle formation by mainly bottom-up nanosynthetic approach, and various metal ions and metal oxides that can be produced, or sulfides, by this process. And this biogenic process can be affected or can be tuned by changing the pH, temperature, time of reaction on the concentration of the precursor solution, or the quantity of the biomass or agitation, or the quality of the microbial biomass, light intensity, etc. The points. And these parameters actually leads to the final nanoparticle formation. So we can tune, we can optimize the situation to get whatever we just want to do. And they have shown in the study, several studies, they have shown their antibacterial, antifungal, antioxidant, as well as anti-cancer agents. They are quite successful. And yeah, overall the method is simple, efficient, easy to execute, clean, economical, and green. So there are some limitations, like some methods they are not explored yet, and the established methods, they need more time, like 10 hours. We have seen that the gold nanoparticle needs 10 hours. So 10 hours we can allow if not compromising with the quality or the structure of the nanoparticle we are getting. We can compromise with 10 hours, but whenever there is a longer time, that time we need to tune the situation. So more studies are required for this field as well. Thank you. And if there is any question, ma'am, I can't hear you, ma'am.
Good morning. Good morning to all. I am Dr. Nidhi Asthana. Thank you, Dr. Binita Datta, for your very much recent progressive in nanoparticles. So, anyone want to ask questions? So, please. Okay. Thank you, Dr. Binita. Thank you again.
Yes,
The next short invited lecture, Dr. Anuja from Guru Govind Singh, Indraprasth University, Delhi. Her topic is applicability of green synthesized iron nanoparticles in acid fusion dye decolorization. Please, Dr. Anuja, proceed.
Okay.
Is my presentation visible?
Yeah, you are visible.
Okay. Okay. Good morning, all of you. The topic, I am Anuja from University School of Environment Management, Guru Gobind Singh Indraprastha University, Delhi, India. The topic of my short invited lecture is applicability of green synthesized iron nanoparticles in acid fission dye decolorization. So this is a brief outline of my talk. I'll be giving introduction, then iron nanoparticles, water treatment, dyes in wastewater, nanoparticle synthesis and characterization, and application in dye decolorization. Introduction. What are nanoparticles? The materials consisting of small grain sizes in the range of 1 to 100 nanometers, that is called nano range, and consisting of more than one dimension, of which at least one dimension should be nano range, as referred to nanomaterials or nanostructures. These nanoparticles exhibit several properties which are different from their bulk counterpart because of their small size. These properties could be catalytical, electrical, optical, thermal, or antimicrobial. So because of these properties, the nanoparticles could be used in various fields like water treatment, communication, agriculture, energy, medicine, cosmetics, consumer goods. So the question arises, why I have used iron nanoparticles? The answer to it is because usually when we use gold or silver nanoparticles, they are not economically very much favorable because of their high cost. But iron is comparatively low in cost. Plus, iron nanoparticles exhibit magnetic properties so that they can be easily recovered after the treatment. So, there are different methods for the synthesis of iron nanoparticles. These could be physicochemical methods or biological methods. Physicochemical methods can further be divided into two parts, which is top-down approach and bottom-up approach. The top-down approaches include ball milling, etching, laser ablation, sonochemical synthesis, thermal decomposition, or vacuum sputtering. Bottom-up approaches include aerosol process, atomic condensation, co-precipitation, Fenton process, hydrothermal synthesis, chemical vapor deposition, microemulsion, salt gel process, and thermal decomposition. In addition to it, several biological methods could also be used for the synthesis of iron nanoparticles, which can be divided as using plant extracts or using microbial synthesis. Plant extracts which could be used are leaves, flowers, seeds, fruit peels, or and microbial synthesis could be done using algae, bacteria, diatoms, fungi. So, background. Where I'll be using the iron nanoparticles which I have synthesized. As we all know, we have 17 goals for transforming our world as per UN Sustainable Development Goals. One of which is goal number 6, that is clean water and sanitation. Since water is an essential for facilitating life on Earth, so to facilitate the proper functioning of our organism, it should be free from harmful chemicals and microbes for its safe use and consumption. But hasty industrial activities all around the world is leading to pollution of water resources due to organic and inorganic contamination. Both developing and developed nations are facing this problem. Water pollution, as per a report, water pollution leads to death of 14,000 people on a daily basis, which is a very big number. One major source of contamination of it is industrial dyes. Every year, 1 lakh dyes and 7 lakh tons of synthetic dyes are commercially used, of which 10 to 15% of these dyes do not bind to fabrics and find wear in wastewater. And they lead to organic and color load in wastewater and its contamination. So I have used acid tristan dye in acid tristan dye for treatment. The structure is provided in the image. Its usage, usually it is used in textile, fabrics, silk, nylon, wood, wool, and leather industries for their for imparting color to them. It is also used as a laboratory reagent. It is also used as a corrosion inhibitor. So what are the negative impacts of this dye if it is discharged in wastewater? It is highly toxic and carcinogenic in nature. So it is very much important to treat this dye. Various biological methods are also used for treatment of this dye, but biological methods are usually take a large amount of time. Plus, when we use biological methods like bacteria or fungi, we face problem of contamination also. So synthesis of iron nanoparticles. First of all, I have prepared plant extract. For this, usually what is done is people use fresh plant extract. So we are consuming a resource, a natural resource. But what I have done is I have used sal deoiled cake for preparing of extract, plant extract. So why sal? So answer to this is because sal is an important forest tree in India. Sal seeds are key forest byproduce. These are high in fat content. That is why they find industrial usage. As per my knowledge, sal deoiled cake is a novel biological waste material used for my iron nanoparticle synthesis. So why I have used sal deoiled cake is there's also a reason that the deoiled, when we extract oil from sal cakes, this leads to this is having when we after extracting the oil, this leads to deoiled substances which constitute 88% of it, which is high in starch and tannins. Tannins are polyphenolic compounds which can act as reducing agents. So for this, I have collected the sal deoiled cake, and 20 gram of it is weighed and rinsed with distilled water. Then it is churned in mechanical grinder, and then a suspension was boiled for 5 minutes. And after cooling it down to room temperature, the extract was filtered through muslin cloth and filter paper and centrifuged to 10,000 rpm for 10 minutes. The supernatant was collected in a separate flask for further processing. For synthesis procedure, iron nanoparticle synthesis procedure, I have used the sal deoiled cake extract as a reducing agent for reducing FeCl2 and FeCl3 salts at 80 degrees Celsius at 1000 rpm magnetic stirring. As we add sal deoiled cake extract to iron salt solution, we notice a color change. The color of the iron salt solution changes from orange to black, which is an indicator of iron nanoparticle synthesis. When I have raised the pH of this salt solution, and iron nanoparticles are synthesized, which are further vacuum dried and used for decolorization. So I have characterized these nanoparticles using XRD, HRTM, and FTIR. In XRD, crystal planes of 200, 311, 400, 422, 511, 440, 533 can be seen. And crystal size was calculated using Scherer's equation and found to be 4.90 nanometer. When characterization using HRTM was done, it was found that the nanoparticles were spheroid in nature, and when HRTM image was seen for further magnification, it was noted that D-spacing was found to be 0.25 nanometer, which corresponds to 311 plane and indicates metallic state of iron oxide nanoparticles. Seed pattern was also observed for these nanoparticles, and it was found to be that ring-like pattern with bright spots was observed due to different planes. And this indicates the crystalline nature of the iron nanoparticles. When I have done the FTI imaging of both Sardi oil cake and iron nanoparticles, it was found that the orange line depicts Sardi oil cake solution and the blue line depicts the nanoparticles. It was found that the peak of Sardi oil cake solution was reduced, which is probably due to chemical change in them, and different peaks were observed in this range. So these peaks are majorly due to stretching vibration of OH, CH stretch, C double bond C vibration of stretching, C double bond C stretch of aromatic vibration, and CO stretching and deformation band of the organic products. So when I have used these nanoparticles for decolorization, after 24 hours of treatment, it was found when I have used 10 ppm of acid fusing dye, we have observed 36% decolorization. And when I have increased the concentration of dye to 50 ppm, I have observed 91% of decolorization. On further increasing the dye concentration to 100 ppm, we have observed 92% decolorization. So it was seen that as I have increased the concentration of dye, we have observed increase in the decolorization, percentage decolorization. So for further experiments, we have used 100 ppm of acid fusing dye. We have done, we have changed the concentration of the nanoparticles, and we have also did the time studies. For changing the concentration of nanoparticles, we have observed that different decolorization percentage was observed, like 13%, 47%, and 91%. And when we have done the time studies, we have seen that we have done till 4 hours, and we have observed that 91% decolorization using 50 mg nanoparticles was done. And we have also observed that after approximately 1 hour, the decolorization becomes constant. So this might be due to the adsorption process, because after once the surface of nanoparticles was consumed, so there's no more sites available for attachment of the dye. We have also seen that this is the decolorization as at 545 nanometer, but we have also observed decolorization change in any peak has occurred in the UV region, but we have not seen any peak in the UV region. That also depicts that probably the decolorization was due to adsorption only. Thank you.
Sorry. Hello.
Yes, ma'am.
Thank you, Dr. Anuja, for your learning experience to share with us. And anyone want to ask question, please proceed. There is no questions. Thank you again, Dr. Anuja.
Thank you, ma'am.
Now, our next speaker is Reshma R. Pillai from Department of Chemistry, Kerala, India. Her topic is antibacterial, anti-cancer, antioxidant, and anti-diabetic activities of biosynthesized copper oxide nanoparticles. So please, Dr. R. Pillai, please proceed. Dr. Reshma,
Yes, ma'am.
are you there?
Yes, I am here.
Okay, please proceed your lecture.
Ma'am, can you see me?
Yeah, I can. Your slide is showing, so please.
Okay, ma'am. Ma'am, I'm Deshma Pillai from the state of Kerala, India, and I'm doing research under the guidance of Dr. Meera AP, Iscmnb College, and affiliated under the University of Kerala. My research topic is the biosynthesized metal oxide nanocomposites for and biomedical applications. Now I am presenting a part of my research work. I thank the organizing committee members for giving me an opportunity, golden opportunity, to be a part of this conference. The title of my presentation is Antibacterial, Anti-Cancer, Antioxidant, and Anti-Diabetic Activities of Biosynthesized Copper Oxide Nanoparticles. The contents of the presentation are introduction, biosynthesis of copper oxide nanoparticles, characterization techniques, application studies of copper oxide nanoparticles, and finally the conclusion. Introduction. Nowadays, metal oxide nanoparticles gain more attention due to their wide range of applications in optoelectronic in various fields like optoelectronics, nano devices, sensors, catalyzers, information storage, etc. Due to their unique physical, chemical, electronic properties rather than their bulk counterparts. Now, we synthesis copper oxide nanoparticles are because they are used as disinfectant for decades because of their strong antibacterial properties. Copper oxide nanoparticles have applications in pharmaceutical, electronics, environmental healthcare catalysts, in gas sensors, high temperature superconductors, solar cells, etc. We adopt green synthesis method because it is an eco-friendly, cost-effective bioproduction method for the synthesis of nanoparticles. And it requires only low energy. In this green method, we use plant extract for the synthesis of copper oxide nanoparticles because plants contain biomolecules like ketones, aldehydes, carboxylic acids, terpenoids, phenols, etc. And these biomolecules are responsible for the reduction of metal ions to metal nanoparticles, as well as they act as stabilizing agents. In the present study, copper oxide nanoparticles are synthesized using pimenta dioica leaf extract as reducing agent. Pimenta dioica, commonly known as Saprophygenthi, belongs to the family Myrtaceae, and it was already reported to have antibacterial, antifungal, antioxidant activity. They contain flavonoids, terpenoids, etc. These act as the reducing agent, act as the reducing as well as the stabilizing agent. The biosynthesis of copper oxide nanoparticles. In this method, the only chemical used is the copper concentrate pentohydrate. The fresh leaves of Saprophygenthi were collected, washed, dried, and powdered. Systematic representation of the synthesis procedure is shown here. Here, the green leaves are collected, washed, dried, and powdered. This extract 100 ml of is mixed with the copper sulfate and 24 suspension. And these then centrifuged, dried, and calcinated at 500 degrees Celsius for 2 hours during copper oxide nanoparticles. Next, the characterization techniques for characterize the nanoparticles are spectroscopy, Fourier transform infrared spectrum, X-ray analysis, chem analysis, and semi-DAX. From the UV visible spectrum, we get a broad absorption peak of about 49 nanometers, and this confirms the formation of copper oxide nanoparticles. Next, the FTF spectrum of pimenta dioica leaf extract and the copper oxide nanoparticles. Here, the FTF spectrum of pimenta dioica leaf extract shows 15 peaks at 3,405 pixels, corresponding to OH stretching by antibody of phenolic. 2,920 for pH stretching, 1,615 for C double bond stretching, and 1,069 for the peak set 1,580 and response carboxylate. But in the fact of copper oxide nanoparticles, they peak at 5 nanometer corresponds to the CU or stretching, and this informs the formation of copper oxide nanoparticles. Other peaks such as peak confirm the oil. The absence of other suggests that the responsible for the bioreactive copper ion copper nanoparticles. Study analysis. Study analysis.
Excuse me, Dr. Reshma. Your voice is not clear. Excuse me, Dr. Reshma.
Here, heavy rainfall here.
Dr. Reshma, can you hear me?
The semi-image is about the pivot-shaped formation of pivot-shaped or platelet-shaped nanoparticles. From the nucleus spectrum, only the presence of copper and oxygen were found. Other impurities were found in this gas image. Only the percentage is about 53.43% copper and 46.5% oxygen were only found. And this confirms the system found the copper. The same image, the intershaped nanoparticle size ranges about 3 to 15 nanometers was confirmed by the analysis. Next, after study copper nanoparticles, the antibacterial effects of copper nanoparticles studied for their antibacterial activity against 4 common dust pathogens, such as S mutant, reorganized antibiotics, at different concentrations. And we shows that copper nanoparticles shows a concentration dependent activity against all the tested pathogens. The one of the reasons for a strong antibiotic action, all size and higher suffocated to molecule, but the membrane of the cell. Also, the tendency to alter the oxidation state because the chemical structure of DNA and binds other damage the protein. Produce toxic hydroxyl bacteria. Structure the cell if any antigens cytotoxic effects of the DLD1 colorectal cancer, one of the main cancers of cellular studies of antigen structure of synthesis nanoparticles shows that at a 24 hours of patient period, a significant reduction in the cell viability was observed with DLD1 cell line, which increased the concentration of the nanoparticles from 0.25 to 100 micrograms. Or here the IC value taken. The plot shows the antigen tracking of the nanoparticles on this line. And the cytotoxic L9 other cells, cell lines showed more viability but study concentration. The IC value here is 190 than the IC value LD. So, cytotoxic optical image study for copper of the nanoparticles 199 and this shows that more viability cell line to definite study concentration. Antigen specific copper DLT1 cell line. From the image, you can clearly see that when the concentration of copper nanoparticles increases, viability of the cell increases. Next thing is study the antioxidant activity. The free radical scavenging is involved. The most popular method of studying the antioxidant activity is scavenging assay. This is DP-based radical. In this method, decrease in the absorption of the DP-based solution on the addition of an antioxidant was measured at a 570 nano. Copper nanoparticles show concentration dependent free radical scavenging, confirms the antioxidant nature of the nanoparticles. The table shows the percentage inhibition of based and antioxidant activity of the copper oxide nanoparticles upon the concentration, upon the increasing concentration. Next, to study the anti-diabetic activity, alpha amylase is thought. The pancreatic acid alpha amylase is a carbohydrate digestive enzyme, stops the production of monosaccharides by hydrolyzing the alpha bonded polysaccharides and oligosaccharides. Hence, the inhibition of this enzyme slows down the process and reduces storage of excess glucose in the body. The biosynthesis of copper nanoparticles are found to inhibit carbohydrate digestive enzyme alpha amylase. The bar diagram shows the alpha amylase increases the copper oxide nanoparticles with the increasing concentration. Conclusion: copper oxide nanoparticles are effectively synthesized in method using limited IOK extract. The biosynthesis nanoparticles have effective antibacterial activity against both the gram classes of bacteria. Copper oxide nanoparticles exhibit strong cytotoxic activity against PLD1 cell lines, but less toxic than normal cell lines. TP-based free radical scanning confirms the antioxidant nature of the nanoparticles, and also the copper oxide nanoparticles are found to inhibit carbohydrate digestive enzyme alpha amylase.
Thank you so much, Dr. Reshma, for your wonderful presentation. And now the time for the questions. So please, those who want to ask question, they can. No questions? Okay. Thank you again, Dr. Reshma, for your wonderful presentation. The next speaker is Vanita N. from Sri Param Kalyani College, Sundranar University, Tirunelveli. Her topic is a study of electrochemical devices based on sodium alignate with ammonium salt biopolymer electrolyte. Dr. Vanita, are you there? Dr. Vanita, can you hear me?
Yes, ma'am. Yes, ma'am. Hear me, ma'am.
Okay. Please proceed your lecture.
Yes, ma'am. The presentation is loading, ma'am.
Okay.
My screen is visible, ma'am.
Not now. It's loading.
My screen is visible, ma'am.
No, it's not visible. I think it's internet problem or something else. It's not visible.
Just a moment.
Yes, ma'am, I'm here.
Dr. Bhargavi Devi is from Faculty of Dental Sciences, Ramya University of Applied Sciences. Her topic is the anti-carcinogenic efficacy of nano silver fluoride review article. So please, Dr. Bhargavi, you can proceed.
Yes, ma'am. Can you see my screen, ma'am?
No, it's not visible.
I've shared it already.
It's not visible now.
Okay. Now, ma'am?
No.
Morning, everyone. Sorry for the error which I was causing. And I'm Dr. Bhargavi from the Department of Pediatrics and Preventive Dentistry from the Faculty of Dental Sciences, Ramaya University of Applied Sciences. And today I'm going to talk about the anti-carcinogenic efficacy of nanosilver fluoride, and it is a review. So I'll be covering the lecture under the following contents. So, dental caries is defined by Schaeffer's as an irreversible microbial disease of the calcified tissue of teeth, characterized by demineralization of inorganic portion and destruction of the organic substance of tooth, which often leads to cavitation. So, traditionally, the most common mode of treatment which was followed was cavity preparation, by which we remove all the decayed part from the tooth and fill the part which has been cavitated now with a restorative cement. This could either be a GIC, amalgam, or a composite restoration. So, in the contemporary times, we have become more conservative in treating the dental caries. That is, we have moved from this invasive technology of preparing cavity and restoring it to a more conservative way. Like that is, we have started using the minimal invasive dentistry. So, in the main principles of minimal invasive dentistry can be summed up as 4 R's. That is recognition, by which we mean that we have to recognize this dental caries at an early stage. The second one will be reduction. So we have to promote lifestyle changes like change of dietary habits, more oral hygiene, all that, and that will help in reducing the risk factors for dental caries. And the third one will be repairing. So whatever decay that has already happened, like in the initial stages, and not yet cavitated it, those we try to regenerate them, and which have already cavitated, we try to practice invasive dentistry, but in a very minimal fashion. So this is what we mean by minimal invasive dentistry. So in this end, the regenerative therapy is what we are looking at right now, because that will prevent the progression of dental caries, and it will also revert the decay from the demineralized state to the remineralized state. That is, it will essentially shift the equilibrium towards remineralization. So in that line, we have diverse chemotherapeutic agents based on fluorides. So in that line, we have the latest material, which is nano silver fluoride. So moving on to the history of silver, as we know, it is a transition metal and it is also a natural biocide, and it has been used in medicine since the time of Hippocrates to treat burn wounds because of its antibacterial as well as healing properties. And in dentistry, we have been using silver in the form of silver amalgam since the 18th century. And because of this we use because of its mechanical and physical properties and also because of its biocompatibility. So in 1891, Stebbins reported that teeth that were restored with amalgam displayed a black surface. Underneath that, there was no progression of dental caries. And subsequently, in 1917, Howe found that when silver nitrate solution is applied to caries lesion, the similar results are observed. That is, the caries progression was arrested. And also, so from that time on, Howe's solution, that is the silver nitrate solution, has been used for over 50 years. Then a series of clinical studies were conducted, and they proved that the anti-caries efficacy of silver and fluoride combination. So in 1970, Dr. Yamaha and Dr. Nishino in Japan introduced silver diamine fluoride, and studies of silver fluoride demonstrated an anti-caries effect. But later they started recognizing that the surface which were treated with silver diamine fluoride started staining black. So the researchers started their search for a novel material which will have the same efficacy as that of silver diamine fluoride while not staining the tooth. So with the advent of nanotechnology, this dentistry had a boom with respect to the armamentarium which we have right now. And so nanodentistry is the use of nanotechnology in diagnosis, treatment, and prevention of oral and dental diseases. And nanomolecules and nanoscale silver nanoparticles are the second wave of silver products developed as a result of the recent development in manufacturing and biomaterial science. And size reduction, what is speculated is that with the reduction of the size of silver nanoparticle, the toxicity as well as the staining associated will also be reduced. So coming on to the mechanism of action of nano silver fluoride, as we have seen earlier, dental caries is a microbial disease and there is also demineralization. So if we can address both of these issues, we are finding a solution to that. So the material which we use must have both antibacterial effect as well as the remineralizing property. So the first effect which we are going to discuss will be antibacterial effect. And according to many authors, silver nanoparticle can penetrate the bacterial cell wall and cause direct and indirect lipidic peroxidation. So what happens is, once the silver nanoparticle enters into the bacterial cell, it will increase the permeability of the bacterial cell membrane. So the acid ions, that is the protons which are present in the environment, will enter into the bacterial cell and thereby start causing destruction. Secondly, the silver nanoparticle will bind with thiol groups of the proteins present in the bacterial cell. So this will cause inhibition of the bacterial proteins as well as enzymes, and also binding of silver nanoparticle with DNA will prevent its replication. So the cell division is also stopped. So the bacterial cell cannot divide and cannot proliferate, as well as the lipid peroxidation, that is when it reacts with the cell membrane of the bacterium, it is causing peroxidation. As a result of peroxidation, a lot of free radicals will be generated. So these free radicals will also cause damage to the bacterial cell. So ultimately what is happening is the bacterial cell is killed. Okay. Secondly, this nanosilver fluoride also has fluoride, and by numerous studies and as quoted by Marquez et al. In 1995, we see that fluoride has got inhibitory action on the bacterial enzymes, and it also increases the susceptibility of cells to the acidic environment. This happens because once fluoride enters the bacterial cell, it will increase the permeability to protons present in the environment, which will further lead to bacterial damage. So ultimately what is happening because of silver and fluoride is that the bacterial cell is getting killed. Second effect which we have to talk about is the remineralization effect. And fluoride is the chemical which when it gets absorbed into the tooth and bones, it gets incorporated into the hydroxyapatite lattice structure and makes it fluorapatite. And this fluorapatite, the most striking property of this fluorapatite is that it is very resistant to acid. So it won't dissolve when there is an acidic environment in the oral cavity, like when it happens when we are going to take a sugary food. So when we take sugary food, the bacteria present in the oral cavity will ferment the sugar and convert it into acids. So in the presence of this acid, the normal enamel mineral, which is the hydroxyapatite, will start dissolving. That is when demineralization is happening, we say. So when we can shift this demineralization in favor of remineralization, the process of decay will be stopped. So fluoride stimulates remineralization of teeth even at micromolar levels, and this impact is believed to play a key role in fluoride's anti-Caries activity. Secondly, silver nanoparticles can infiltrate into the demineralized area and can precipitate at that particular site, resulting in an increase in enamel hardness and also it increases the resistance to demineralization. So now we have seen how nano silver fluoride has got anti-Caries effect as well as demineralization effect. And various techniques have been proposed for the synthesis of nano silver fluoride, the first of which was given by Targino et al. In the year 2014. So the method used by Targino et al. Is that they dissolved silver nitrate and chitosan separately. So chitosan was dissolved in 1% acetic acids, and after this is dissolved, silver nitrate is added, and it was mixed using magnetic stirring, and the mixing was done homogeneously. So the mixture is transferred to an ice cold bath, and freshly prepared sodium borohydride is added drop by drop, that is titrated, until they see a color shift from a golden brown to from a brown to golden brown color. So once this golden brown color is achieved, what we notice is that silver nanoparticles have started precipitating. So the flask is then removed from the ice bath and sodium fluoride solution is added, and stirring was maintained overnight, and the product which we get at the end is nano silver fluoride. So this method of synthesizing nano silver fluoride was followed by Santos et al., Nanda et al., Nagireddy et al., Atta, and Elzayat, to name a few. And in this method, what they have done is the reducing agent is sodium borohydride and chitosan is the stabilizing agent. The next method was given by Hagu et al. So they proposed a weight dilution method for the preparation of nano silver fluoride. And in the original article presented by Hagu, what he has stated is that he has tried a series of concentrations of silver nanoparticle to be added to the fluoride varnish, and found that any concentration above 1% is efficacious in having its antimicrobial effect against Streptococcus mutans, which is considered to be the key bacterium in causing dental caries. So in a study by Tripathi et al., what he has done to prepare nano silver sodium fluoride varnish is that he has added 0.5 gram of silver nanoparticle powder to 10 ml of 22,600 parts per million of slow release sodium fluoride varnish, fluoritop varnish, and vigorous mixing was done to achieve a uniform dispersion of the nano silver particle. So the product which we achieved by the end of this process is nano silver sodium fluoride. The next method was pretty recent. It was given in the year 2020. So in this method, what they have done is they have used polyethylene glycol thiol as the reducing as well as the stabilizing agent, and the salt of silver which was reduced here is silver acetate. So in the study, 40 milligram of silver acetate and 20 milligram of polyethylene glycol thiol were dissolved individually in 400 ml of ethanol. Then silver acetate solution at 4 degrees Celsius was added to the polyethylene glycol thiol solution and stirred homogeneously for 18 hours to promote the formation and growth of nanoparticles of silver. So by the end of this, they have achieved polyethylene glycol coated silver nanoparticles, and this was concentrated using rotary evaporation after the ethanol was changed with water. That is, the medium was changed from ethanol to water, and evaporation was done to get a concentrate. So from 400 ml, they have reduced the concentration by evaporation to 50 ml. And for this solution, they have then added sodium fluoride at 2.5% concentration to yield a fluoridated polyethylene glycol coated silver nanoparticle solution. So this contains about 11,310 parts per million of fluoride and 400 parts per million silver. Okay. So various in vitro studies were conducted to prove the antibacterial effect of silver nanoparticles. So these studies have stated that silver nanoparticle has the minimal inhibitory concentration and minimal bactericidal concentration values much lesser than the standards such as chlorhexidine and silver diamine fluoride. So what they are trying to tell us that the concentration of nano silver fluoride required to have the antibacterial effect is very much smaller than the standard materials. The in vitro studies have also proven that. What happened? Ma'am, I think Dr. Vanita has started screen sharing. Hello. Ma'am, you have not unmuted yourself.
Sorry.
Yeah.
Dr. Vanita.
Yes, ma'am.
Your screen is shared here.
So now we saw that silver nanoparticle has got antibacterial effect as proven by studies conducted by Hagu et al., Targino et al., Nozari et al., and Texiera et al. So the next property which they try to prove by the in vitro studies is a remineralization effect. So what they have proved is that compared to nanohydroxyapatite serum and fluoride varnish, nano silver fluoride has got the greatest remineralization effect. This study was conducted by Nozari et al. So moving on, a digital spectrophotometric study revealed that dentine staining caused by nanosilver fluoride is much lesser when compared to that of the silver diamine fluoride, and thus it does not compromise the aesthetics. And also, the smaller the particle size of silver nanoparticles, lesser will be the stain. So when we are going to reduce the silver nanoparticle size to about 10 nanometer, there was virtually no staining that was observed. So in addition, it was also proven by an in vitro study that pre-treatment of the teeth with nanosilver fluoride increased the resistance of glass ionomer cements and composite resin restoration to secondary caries. So before we restore the tooth with these restorative cements, if we apply a layer of nanosilver fluoride, what they have found is that the occurrence of secondary caries has reduced. So this was done by Hagu et al. And according to a study done by Zayed et al., silver nanoparticle potassium fluoride and potassium fluoride group had the same intrafibrillar pattern of mineral deposition. That is, there is a biomimetic remineralization occurring when nanosilver fluoride is applied onto the tooth. And they have also found that the nanosilver fluoride, when applied to the dentine, does not cause any collagen fiber destruction. So it is highly biocompatible, and it does not cause any dentinal staining when applied on the dentine as well. But when SDF was applied, what they found is the SDF has caused some amount of collagen fiber destruction. This is happening because of the high causticity of SDF, but we don't have that causticity associated with nanosilver fluoride. And many randomized control trials on humans were conducted. So the first trial was conducted in the year 2014 by Santos Jr. et al. So they did a study on in primary teeth of children, 130 primary teeth of children. So in the they have compared the nanosilver fluoride with that of water as control. So the finding of this research is that nanosilver fluoride group had about 72.7% of teeth with arrested decay, whereas the control group had only 27.4% of tooth with arrested decay. And at the end of 12 months, 66.7% of the tooth treated with nanosilver fluoride were still arrested. That is, they have applied it only once, and the effect was there for over a period of 12 months. That is, up to 1 year, they could see the effect. The second one is the study conducted by Tripathi et al. In the year 2019. So he has conducted the study on 159 active dentinal caries lesions in primary molars from 50 children, and they have compared 5% nanosilver sodium fluoride varnish with that of silver diamine fluoride varnish, and they stated that the success rate associated with 5% nanosilver sodium fluoride varnish was 77% at the end of 12-month follow-up. And in 2019, Nagi Reddy et al. Conducted their study on 100 deciduous molars from 60 children, and they have compared the efficacy of nanosilver fluoride against saline as the control group. So, and they found that 78% of the teeth showed arrest of dentine caries in the NSF group after just 7 days. That is, after day 1, on the 7th day only, they could see about 78% of the teeth were arrested, and this arrest was maintained to about 65% at the end of 12 months. So, over a period of 1 year, almost more than half of the teeth that were treated with nanosilver fluoride solution were effective in maintaining the arrest. So what are the conclusions that we can draw from these in vivo studies is that application of nanosilver fluoride can arrest dental caries in about 65 to 70% of cases with no substantial difference between NSF and SDF, that is silver diamine fluoride and nanosilver fluoride. Also, once yearly application of nanosilver fluoride has the same clinical efficacy as silver diamine fluoride in preventing the progression of dentinal caries in primary posterior teeth. So moving on to the advantages of nanosilver fluoride, it is a very non-invasive technique of application. So The technique of application is that we have to dispense a nanosilver fluoride solution in a container, say a DAP and dish, and we have to use an applicated tip. We have to isolate the tooth. We have to keep it clean and dry, and then we have to apply the solution onto the tooth surface by using the applicated tip. It is as simple as this. And so, when we are talking about doing this treatment in children, preparing a cavity and making them sit throughout the procedure is not very easy. Children have very short attention span, and also that they won't be very cooperative in the dental chair. But this procedure will be very easy, and it doesn't require patient's cooperation to perform this procedure when we are talking about a child as a patient. And it is more cost effective than 38% SDF, and there is no discoloration of teeth, or there is no chance of soft tissue lesion upon accidental contact. These two are seen when we are going to use SDF as the treatment option, and there is no associated metallic taste with nanosilver fluoride, and it has got a proven antibacterial and remineralizing effects, and the requirement of minimal armamentarium is also an advantage, and there is also simplicity of treatment, and above all, it is highly biocompatible. So the futures. So this is the literature review which we saw so far. So the future scope will be the studies which were conducted so far on humans were single-centered, and they had a very small sample size. So we can plan a multi-center study with larger sample size so that we can generalize the results we get from those studies. NSF concentration and composition can be standardized, because in all these studies, the concentration they have used was very different. Tripathi had used 5%, and in another study they have used 400 ppm. So we can figure out which is the standard concentration that can be used when we are going to make a ready-made product. And the primary health workers can be trained with this technique, because when we are talking about rural population or population who are underserved, they won't have the accessibility to go to a private dental clinic setup to get their treated. So, but they will always be in contact with the primary health workers. Like in India, we have something called ASHA workers, and also we have primary health centers where they will be children will be first going there, like to get their vaccines. So if we can train these primary health workers regarding the use of this technique, then we can stop dental caries at a very early age. We can prevent its progression. We are also addressing the underserved population. So to conclude, nanosilver fluoride is an economic, ergonomic, non-invasive agent that is safer in children and adults. Also, it is biocompatible, non-discoloring, non-caustic, and more efficient than the conventional fluorides in SDF. Thus, NSF is a better anti-caries agent, outstripping the limitations of SDF. These are my references. Thank you.
Okay. Thank you, Dr. Bharkavi, for your great presentation, for sharing your review article. Now the platform is open for the questions. Those who want to ask questions, they can.
Hi, I have seen your presentation. I just bit queries for your presentation regarding nano silver fluoride. You are asking, what is the dimension of your nanomaterials?
Sir, in different studies, the nano particles which they have generated are of different size, sir. So, on an average, it was from 10 nanometers to 20 nanometers, sir. So,
why you choose the silver nanomaterials?
Because silver, as we have known from ancient times, that it has got antibacterial effects, sir. And it is also biocompatible, and it does not have toxicity when it is going to be used in very minimal concentrations as nanoparticle. So it is very biocompatible, so we can use it inside the oral cavity.
But you have written that silver nano silver fluoride something else. So it will be, I think, silver nano because nano silver not. It is called silver nano, right? So
no,
what?
There are two products, sir. One is silver nanoparticle based product. This product is named as nanosilver fluoride only.
Okay. So what is the synthesis procedure? I mean, which synthesis procedure you employed for this?
Sir, I have not made this. I have presented a review. So they have this product was first introduced by Targino et al. In the year 2014, sir. So nanosilver fluoride is the solution they have prepared. They used silver nitrate and chitosan as the stabilizing agent, and they have reduced it by using sodium borohydride.
So rather than antibacterial properties, did you attempt any other application?
Yes, sir. We have checked for remineralizing effect as well. So the remineralizing effect is that when we apply nanosilver fluoride, what they found is that silver nanoparticle is getting incorporated into the demineralized area of the tooth, and it is also not obstructing the collagen framework where the mineralization has to happen. And one more thing is that it has got fluoride in it, and fluoride, numerous experiments were conducted since the 1940s and 50s. Sir. So from that time, we know that fluoride, when we apply on the tooth surface, it is going to get incorporated into the hydroxyapatite structure and change the lattice into fluoroapatite. So this fluoroapatite is highly stable even in an acidic environment, and it will not dissolve in an acidic environment. So what we're trying to say is it is making the tooth more resistant to decay.
Okay. Okay. Thank you. Thank you so much for your nice presentation. Okay.
Thank you, sir. Thank you, everyone. And I would like to extend my thanks to my guide, Dr. Lata Ananda Krishna, and my co-guide, Dr. Pushpalata.
Ma'am, I'm Vanita. Hello. Visible, ma'am? My screen is visible, ma'am?
Yes, Vanita, your screen is visible.
Okay. I'm Manita. My presentation is on a study of electrochemical devices based on sodium alginate with ammonium salt biopolymer electrolyte. And the research scholar Sri Paramakulini College, Alvakuchi, Tenkasi, and Tamil Nadu. Then content of this topic is introduction, experimental method, result and discussion, and finally conclusion. Introduction: in the development of science and technology, the polymer electrolyte has been used a major part in the energy storage devices or electrochemical devices. What is polymer? The polymer is nothing but long chain molecule made up of a repeated pattern on monomers. Polymers can be divided into two types: synthetic polymer and biopolymer. In synthetic polymer like PVA, PVP, and PEV, etc. In biopolymer, in two types of biopolymer, in plant origin and animal origin. In plant origin, cellulose, hemicellulose, agar-agar, and etc. is the plant origin. And animal origin is a citrine, alginate, hyacinth. This is the animal origin. I have chosen for a biopolymer electrolyte. Because of in the recent year, natural polymers have become a promising substitute for the synthetic polymer. So I can choose it for the biopolymer of sodium alginate. Sodium alginate is nothing but this is the brown marine alginate. This is composed of 1 to 4 linked beta D glucurate and alpha L manoate. These are linked by Mg sequence amide. This is the figure of the M block and G block of the sodium alginate. Then I can choose it for the dopant of ammonium thiocyanate. Ammonium thiocyanate is a dopant. This is a good proton donor, and it has a low lattice energy of 605 kilojoule per mole. And when it is dissolved in water, it can be easily dissolved into ions. So I can choose it for a ammonium thiocyanate salt. Then experimental method. Experimental result: sodium alginate polymer and ammonium thiocyanate salt were used as a raw material, and double distilled water as a solvent. The polymer complex of sodium alginate and ammonium thiocyanate are stirred continuously for 2 hours. The prepared solution were cast into the petri dish and kept in oven for 12 hours at 60 degrees Celsius. A freestanding film of about 0.1 millimeter to 0.2 millimeter thickness was obtained after the complete removal of solvent traces. Then finally, we conclude the result and discussion. First, we start the XRD. The XRD diffraction has been used to study the amorphous or crystalline nature of the polymer complex. In pure sodium alginate, diffraction peak at 2 theta equal to 14 degree and 22.8 degree. The two peaks are there in the pure sodium alginate. In the addition of salt in the different composition, 50 molecular weight of sodium alginate and 50 molecular weight percentage of ammonium thioenase and 40 sodium alginate and 60 ammonium thiocyanate and 30 sodium alginate and 70% of ammonium thiocyanate. Added the different composition of salt, it shows a gradual increase of width and decreases of intensity of the polymer salt complexes. This indicates the highest amorphous nature has been obtained. In the highest amorphous nature has been obtained in the 30% of sodium alginate and 70% of ammonium thiocyanate. The broad peak at 27.2 degree. Then further addition of salt, actually 20% of sodium alginate and 80% of ammonium thiocyanate. It shows a intensity peak is increase and width is decrease. It is indicate the amorphous nature will be decreased and the conductivity will be also decreased. Then the percentage of crystallinity, how to calculate this formula used in the crystallinity percentage of the polymer matrix. Area of under crystalline region divided by total area of the peak into 100%. This is the crystallinity percentage of pure sodium alginate is 36.45 and 50% sodium alginate and 50% of NH4SEN is 33.24 and further decreases in the crystallinity percentage and the increases of the crystallinity percentage in the 20 molecular weight of sodium alginate and 80 molecular weight percentage of NH4SEN. Then next characterization is FTR. Then FTR is used for the FTR is a raw feed has been obtained in the O gauge. This is a broad peak. Broad peak is the wave number of 323393 in the pure alginate, 32114 in the 50% sodium alginate and 50% ammonium thiocyanate, and 3201 wave number is the 40% of sodium alginate and 60% of ammonium thiocyanate, and 3191 and 3195 and so on. This is the O gauge stretching. The broad peak indicate the O gauge. The broad peak indicate the O gauge stretching. This indicates that the intermolecular hydrogen bonding has occurred between sodium alginate and ammonium salt. The reason for the peak will be shifted has been reasoned by calculated using the force constant formula. The force constant formula is nothing but nu bar is equal to 1 by c into root of k by mu centimeter minus 1. Where nu bar is the wave number, c is the velocity of light, k is the force constant, and mu is the reduced mass. Then will be calculated the force constant. The force constant will be in the pure sodium alginate is 6.38 and further this 5.73 and 5.68 and 5.64 and finally 5.66. In this force constant, the pure compared to pure alginate and the composition of salt concentration, the force constant will be decreased. So the force constant is decreased. There is increases in bond length and hence frequency is decreases. This is the possible interaction between the sodium alginate and ammonium thiocyanate. Then this is a differential scanning calorimetry, DSC. This is a DSC value of pure sodium alginate is 52.8 degrees Celsius. In the addition of salt concentration, the first addition of salt in the 50%, the TG value is increased slightly in the value of 69.5. This is due to the increases by initial transition cross linkage between the ammonium and polymer. And further addition of salt in the ratio of 40-60 and 30-70, the TG value is decreased. This is due to the value is 65.2 degrees Celsius and 56.2 degrees Celsius. This is due to the transition cross linkage has been broken. The lowest TG value has been obtained in the 30 and 70% of sodium alginate and ammonium thiocyanate in the value of 56.2. This is to indicate the polymer electrode is more flexible. In more flexible, the polymer electrode allows free movement of the ions. Hence, the sample 30% and 70% of NH4SEN has been expected to exhibit the highest ionic conductivity. is ionic conductivity value. And further increase of salt in the 20% sodium benzoate and 80% of NH4ACN, the TG value is increased. This is due to the flexibility of the polymer electrolyte has been decreased. This is indicate flexibility has been increased. Then next is AC impedance analysis. The AC impedance analysis is using the Folker plot. The pure sodium benzoate has a small semicircle and followed by the inclined spike. The semicircle is due to the parallel combination of bulk resistance and capacitance. Inclined spike is due to the electrolyte interfaces. This is a composition of different concentration of sodium benzoate and ammonium thiocyanate salt. This indicates only inclined spike, only the inclined spike. This indicates the capacitive nature is not absent in the polymer electrolyte. This indicates the conduction is due to the ions. The conductivity values has been calculated by using this formula. Sigma equal to L by A RB S C centimeter minus 1. The table shows the ionic conductivity values. The table shows the ionic conductivity values of the pure sodium benzoate and different composition of the sodium benzoate and salt. This is the conductivity also. The highest conductivity values is obtained in the 30 molecular weight of sodium benzoate and 70 molecular weight of ammonium thiocyanate. It is obtained from 8.72 into 10 power minus 3. The conductivity value has been obtained. Then I have chosen for the transverse number measurement. This is a transverse number measurement using the Wagner's polarization technique. Number measurement has been made. This gives the information about the nature of the charge carrier between two stainless steel electrodes. The highest conducting electrolyte sample is placed. The highest conducting electrolyte has been obtained in 30 molecular weight percentage of sodium benzoate and 70 molecular weight percentage of NH4SEN. The DC electric voltage is about 1.5 volt is applied across the sample and the gradual decreases in current, which becomes a stable is absorbed and noted the measurement. The measurement can be using then in the formula T ion equal to II by IF. II is nothing but initial current and IF is nothing but final current. So the T ions value is 0.9753. This indicates the conductivity is mainly due to the ions. This shows the current with respect to the time, the diagram. Then the LSV. The LSV is nothing but this is used to the electrochemical stability of the biopolymer electrolyte. The highest conducting polymer, 30% of sodium benzoate and 70% of ammonium thiocyanate is sandwiched between the two stainless steel. Then figure shows the sudden decreases the current value 2.83 volt, which indicates the electrochemical stability value for the highest conducting polymer electrode. Then finally, I have used it for this. The optimized biopolymer electrolyte using for the construction of proton conducting battery. The battery performance mainly depends on the anode, electrolyte and cathode. The three things are important in the conducting the battery. The zinc metal powder, zinc sulfate and graphite is taken into the ratio of 3:1:1 and grinded well and used as a anode. Lead dioxide, vanadium pentoxide and graphite into the ratio of 4:1:0.5 is taken and grinded well and is used as a cathode. The above mixture of anode and cathode are made into a pellets using the pelletizer. The anode has been taken in the battery holder, then placed over the highest conducting polymer electrolyte like 30% of sodium benzoate and 70 molecular weight percentage of ammonium thiocyanate, and then placed in the cathode. This setup in the shown in the figure. This is the anode. This is the electrolyte. This is the cathode. This is the battery holder. Then in this cell, the open circuit voltage 1.45 volt has been noted for the 60 hours. The cell potential value is drawn 1.2 volt with a load of constant 100 kilo ohm is connected. The current is 15 microampere has been observed. Then finally, the conclusion. Sodium alginate with the ammonium thiocyanate biopolymer electrode has been prepared using the solitary casting technique. The AC impedance analysis shows highest conducting of 8.72 into 10^-93. XRE reveals the amorphous or crystal nature of the biopolymer electrode for various composition of sodium alginate and ammonium thiocyanate. For highest ionic conducting electrolyte, the percentage of crystallinity is found to be have 21.17%. FTR explained the complex formation of polymer and salt. By Wagner polarization technique, we could infer that the ionic conductivity is mainly due to the ions. LS3 shows the electrochemical stability window of 2.83 volt. Finally, the proton conducting battery constructed by using highest conducting polymer electrode and the open circuit voltage as measured 1.45 volt. All the result refers that the prepared biopolymer electrode has been used as a promising element in the solid state batteries. Thank you. My presentation is over. Thank you.
Thank you, Dr. Vanita, for your great presentation.
Thank you.
Now the platform is open for questions. So anyone want to ask question, they can. Okay, I think there is no question. So again, thank you, Dr. Vanita, for your nice presentation.
Thank you, ma'am.
Our next speaker is Jitya Suresh.
Yes, ma'am.
Okay. She is from Faculty of Dental Sciences, Rama University, Bangalore, Karnataka. Her topic is Method of Synthesis of Zinc Oxide Nanoparticle, a review article. So, Dr. Jitya, you can proceed.
Yes, ma'am. Thank you. Good morning, everyone. I'll be talking about the methods of synthesis of zinc oxide nanoparticles, and it is a review on the various methods that are there. Coming on to the introduction, so we all know that zinc is an essential trace element which is found in the muscle, bone, skin, and hard tissues of the tooth. Zinc oxide nanoparticles are a white colored odorless powder, and it has a molecular weight of 81.38 gram per mole. And FDA considers this as a generally recognized as safe substance. The extensive applications of zinc oxide nanoparticles in the various fields of dentistry, such as prosthodontics, in the biomedical waste management, in cancer diagnosis, in regenerative endodontics, in orthodontics, in endodontics, in oral medicine, in implantology, periodontics, restorative dentistry, and in preventive dentistry is what sparked my interest about these nanoparticles. So the applications are owed to its unique optical, magnetic, morphological, electrical, catalytical, mechanical, and photochemical properties. And these properties of zinc oxide nanoparticles can be easily altered as per the requirements. That is by altering the size, by doping with supplementary compounds, or by adjusting the conditions of synthesis of these nanoparticles. So based on adjusting these conditions of synthesis, several morphologies of these zinc oxide nanoparticles, such as nanorings, nanohelices, nanowires, nanobells, nanorods, nanotubes, and cone-shaped nanoparticles can be obtained. So, coming on to the strategies that are used for the synthesis of zinc oxide nanoparticles. As with any other nanoparticles, there are two strategies for the synthesis of even zinc oxide nanoparticles, which are the bottom-up and the top-down strategy. The top-down strategy, in this method, the bulk material is converted into nano-sized particle. That is, the preparation of nanoparticles is based on the reduction of size of starting material by different physical and chemical treatments. So it includes methods such as mechanical milling, thermal and laser ablation, wherein a bulk of the material is taken and it is then transformed into smaller fragments. But although this top-down strategy is easier to perform, it is not a suitable method for preparing informal shaped and very small particles. The major problem associated with this top-down strategy is that there is a change in the surface chemistry because we will be treating it with various substances and leading to change in the physiochemical properties of the nanoparticles that are finally synthesized. And a brief about the bottom-up method, which is the other strategy for preparation. It is based on the formation of these zinc oxide nanoparticles from smaller molecules like the joining of atoms, molecules, or small particles. In this method, the nanostructured building blocks of nanoparticles are first formed and are then assembled to produce the final synthesized nanoparticle. So both top-down and bottom-up strategies include chemical, physical, and green means of synthesis. Coming on to the first one, I'll be talking about a few procedures that come under the top-down approaches. The first one being mechanical milling. In this technique, this is one of the physical methods of preparation of these zinc oxide nanoparticles, and the particle size is reduced using a high energy ball in this method. This in turn changes the surface properties of the zinc oxide nanoparticles. So here a bulk powder is added into a container along with several heavy balls, and high mechanical energy is applied on the bulk powder material with the help of high speed rotating balls. Particle size can be controlled using different high energy mills such as attrition ball mills, planetary ball mills, vibrating ball mills, depending on the type of particle that we require. The second top-down approach is the mechanochemical synthesis. Here, the starting materials such as anhydrous zinc chloride, zinc carbonate powder, and sodium chloride are mixed stoichiometrically and milled. During milling, the deformation, the fraction, and welding of the reactants take place. And the heat treatment of the powder can then be done, which was after washing of the powder, and then the zinc oxide nanoparticles can be obtained by a drying process. So the mean particle size with this mechanochemical synthesis method was found to be around 30 nanometer with a nearly uniform shape and narrow size distribution. So this is a very suitable method for the large scale production of zinc oxide nanoparticles. Another top-down method is the laser ablation method. Here, a high purity target material is fixed at the bottom of the glass vessel which has deionized water, isopropanol, and acetone. A Nd:YAG laser beam is used for ablating the material for 3 to 4 hours at room temperature. The colloidal solution is obtained and the particles were found to have an average size of 100 nanometer and spherical shape. Ion spattering is another physical top-down method. Here, silica glass is implanted into the zinc ions and the ion flux was kept less than 2 microampere per centimeter square to keep the temperature below 100 degrees Celsius. For spattering, the samples were irradiated by argon ion beam where they collide and lead to ionization. The positive zinc ion are attracted towards the target where they get impinged, and this can then be extracted and nanoparticles are got. Another top-down method is the solid-state method, which is also called as the ground process. This is a chemical method of synthesis of zinc oxide nanoparticles. Here, zinc acetate dihydrate, CTAB, and sodium hydroxide were mixed, ground in a mortar, and dried, and then zinc oxide nanoparticles are got by this method. So even though the top-down approaches are mainly for industrial purposes and for bulk production, for small-scale production, as in what I would be using, like in the field of dentistry, we would prefer using the bottom-up approaches. That is, we start from smaller particles and form nanoparticles from them. And a brief about a few bottom-up approaches are the co-precipitation method, which is the chemical bottom-up approach method. Here, into an aqueous solution of zinc precursor like zinc acetate or zinc nitrate, an aqueous hydroxide source such as sodium hydroxide is added while magnetic stirring. This is left in stirring condition for about 1 to 2 hours, and the precipitate is then washed several times with deionized or distilled water and ethanol, and it is dried, ground, and calcined to obtain the nanoparticles. Another bottom-up approach. Other bottom-up approaches are the physical vapor deposition and the chemical vapor deposition methods. In the physical vapor deposition method, nickel nitrate and ethanol were dropped into the aluminum oxide substrate. The substrate is then put on top of a quartz boat that is loaded with metal zinc powder and inserted into a quartz tube furnace. The zinc source was physically vaporized to synthesize zinc oxide nanowires. Another very preferred method for small-scale production of these zinc oxide nanoparticles is the sol gel and the modified sol gel method. In the sol gel method, the zinc acetate solution, citric acid, and ammonia solution are the reagents that are used. Zinc acetate is dissolved in water, and then alpha hydroxy carboxylic acid is added in order to coordinate the metal ions that are present. Ammonia and water are then added, and a gel is got which is evaporated and dried, and that is, it is calcined in order to obtain the nano-sized zinc oxide material. Similarly, in the modified sol gel method, which is again a very preferred method for the small scale production, here zinc nitrate hexahydrate and triethanolamine were dissolved in distilled water. Citric acid was added, followed by magnetic stirring at 80 degrees for 1 hour to obtain a gel that was then dried at 120 degrees for 1 hour, and it was ground to fine particle and calcined at temperatures of 470, 700, and 1000 degrees to obtain the zinc oxide nanoparticles. Even though the physical method involved the use of costly equipment, high temperatures and pressure, and it also required large space area for setting up of the machines, the chemical method involved the use of toxic chemicals which can prove hazardous to the environment. Thus, an environment-friendly and cost-effective method for nanoparticle synthesis was developed, which is called as the green synthesis. This includes the use of plants, bacteria, and fungi for the synthesis of these zinc oxide nanoparticles. Similarly, the speakers before me had mentioned the green synthesis of iron and copper oxide nanoparticles. I will be talking about the synthesis of zinc oxide nanoparticles. So here we can make use of moderately pollutant-free chemicals to synthesize zinc oxide nanoparticles by using natural extract. So the main idea behind this biosynthesis is that they contain phytochemicals like saponins, polyphenols, and terpenoids that act as both reducing as well as the stabilizing agents. And plant extracts like leaf, stem, root, fruit, seed have been used. Also, microorganisms like bacteria, fungi, and algae, and other materials can also be used for this green synthesis. So, coming on to a few plant sources that have been commonly researched upon. The first is the Coriandrum sativum leaf or the coriander leaf. Here, distilled water is taken and an aqueous zinc acetate dihydrate was added while under constant stirring. Aqueous leaf extract is then added to this, and 2 moles of sodium hydroxide was added and placed in a magnetic stirrer for 2 hours. The precipitate is then taken out and treated with ethanol for purification and dried overnight to obtain the zinc oxide nanoparticles. Similarly, a Tectona grandis, or commonly called the teak tree, the leaves can be used, and to 5 ml of distilled water, zinc nitrate can be added, and which is continuously stirred for 10 minutes, and the leaf extracts are then added to this solution, and following which a yellow color paste is obtained, and when it is calcined, zinc oxide nanoparticles can be obtained from this. Other commonly researched upon plants that have been studied for the production synthesis of zinc oxide nanoparticles include Vitex negundo, or the Chinese castor tree. The leaf and the flower of this plant have been researched upon for the production of zinc oxide nanoparticles. The leaf and the leaf extract of aloe vera plant have also been researched upon, and have zinc oxide nanoparticles are successfully produced using these. The Azadirachta indica, or the commonly called the neem plant leaf extracts, can also be used to produce zinc oxide nanoparticles. Other flowers that are researched upon are the Trifolium prantans, or the red clover flower, the moringa or the drumstick leaf extracts can also be used, and the Gossypium or the cotton cellulose fiber have also been researched upon for the production of zinc oxide nanoparticles. So this was a brief about the plants that have been, the plant and the plant extracts that have been used for the production of zinc oxide nanoparticles. Coming to a briefing of the bacteria that have been used for the production of these nanoparticles. So even though the use of bacteria is a green approach, it has its own drawbacks and disadvantages, like the fact that the screening of microorganisms is a very time-consuming process, and the culture broth needs to be carefully monitored, and there is a lack of control of the nanoparticles that are produced. The commonly used bacteria for the production of these zinc oxide nanoparticles include Bacillus licheniformis, the Rhadococcus species, and the Aeromonas species. From this table, we can see that the Pseudomonas species generally form a spherical shaped nanoparticles of size almost 50 nanometers. The Basilaceae species form a hexagonal nanoparticles. The Norcaceae form a hexagonal phase nanoparticles again, and the Enterobacteriaceae form a nanoflower shaped nanoparticles. So this was a brief about the bacteria that are commonly researched upon for the production of zinc oxide nanoparticles. Coming on to the algae that have been studied upon, the microalgae and the macroalgae that have been researched upon for the production of these zinc oxide nanoparticles. Algae are a photosynthetic organism that range from unicellular to multicellular ones, as we all know. The microalgae draw special attention in the nano research due to its ability to degrade toxic metals and convert them to less toxic forms. So the algae that are commonly used are Chlamydomonaceae, the Sargaraceae, which form a hexagonal structure and nanoparticles. The Chlamydomonaceae form nanorods, nanoflowers, and these can be used to also produce porous nanosheaths. These were the algae that are used for zinc oxide nanoparticle production. A brief about the fungus that are used for the biosynthesis or the green synthesis of zinc oxide nanoparticles. It was found that the use of fungus is a highly economical method for the large scale production, and convenient downstreaming processing and economic viability was there. So the fungus that have been researched upon are the Aspergillus strains and the Candida strains, and the Aspergillus strains were mostly found to form aggregates which are spherical and hexagonal in shape, and the Candida albicans have found to form nanoparticles which are again quasi-spherical and hexagonal in shape. So a few other green resources that have been researched upon for the zinc oxide nanoparticle production are substances such as egg albumin, which produce spherical shaped nanoparticles, soluble starches, L and Ln, which can form a controlled shape and size zinc oxide nanoparticles. So even though in industrial for industrial purposes we generally prefer the other physical and chemical methods, the nanoparticles that are synthesized by these biological methods have comparatively larger particle size. They are stable because the plant extract and the other natural sources, they serve as both the reducing as well as the capping agent, and have lower photocatalytic degradation efficiency and exhibit higher antimicrobial activity, which can be extremely beneficial for the use in dentistry. To conclude, the application of these zinc oxide nanoparticles is an immensely increased worldwide in different fields like material science, physics, chemistry, and biomedicine. The synthesis of these nanostructures is very dynamic and a very, extremely complex process, and several approaches, as I discussed previously, such as the physical, chemical, and green techniques have been made to synthesize nanoparticles of correct morphology, and each method has its own advantages and limitations. So the biosynthesis of nanoparticles using eco-friendly approach have been the area of focus research in the last decade, and future prospect of plant-mediated nanoparticle synthesis includes an extension of laboratory-based work to industrial scale by introducing precise techniques to overcome limitations of existing methods, leading to proper implementation at a commercial level. Thank you.
Thank you, Dr. Jithya Suresh, for your appreciated work on review article. Now the platform is open for questions. So anyone want to ask questions, they may. Sibikar P. Dr. Sibikar P is there?
Yes, ma'am, I'm there.
Okay.
Can I share?
His topic. Okay. Excuse me?
Can I share my slide?
Yeah, you can. Dr. Sibikar P is from Postgraduate Department of Pediatrics and Preventive Dentistry, Ramia University of Applied Sciences. His topic is nanotechnology in pediatric dentistry. It's also a review article. Okay, Dr.
Is my
Sibikar, you can
slides
proceed.
visible, ma'am?
Yeah, your slides are visible.
A very good morning to one and all present here. I'm Dr. Subika from Department of Pediatrics and Preventive Dentistry from Ramaya University of Applied Science, Bangalore, India. First and foremost, I thank the Lord Almighty, my parents and my mentor, Dr. Pushpalata C, who's my backbone on this field, and Mr. Dinakaran sir and his team for arranging such a wonderful platform for understanding for much about nanotechnology and to share our nano knowledge about this field. So today I'm going to talk about nanotechnology which are used in pediatric dentistry, and it is a review article. So coming to the introduction, in today's world there are many scientists and researchers who have dedicated their life in nanotechnology. But when it comes to the beginning, Dr. Richard Feynman, who's the first person to talk about nanotechnology in his lecture, which is titled as "There is plenty room at the bottom." So he's the first one to talk about this, and he has been considered as an inspiration for this field of nanotechnology. So, what is this nanodentistry? Nanodentistry is an emerging field that aims about to provide a better oral health using nanomaterials or nanorobots and using biotechnology. So, this new treatment opportunity in pediatric dentistry is in variety of uses, including restorative materials or remineralization or any disinfectant, root canal treatment, drug delivering system, and other treatments. So today we'll be seeing about few important treatments which are being considered and done in pediatric dentistry. So basically, what is pediatric dentistry? Pediatric dentistry is a branch of dentistry which deals with specialty, and especially we deals with the children. So when we talk about dealing with children, it is not only about treating them, but also understanding them, their psychology, their behavior management, and also the comfortability. And also, pediatric dentistry is the only field in the entire dentistry who treat special health care children, such as if the patient is having any systematic disease or any mental disorders. So this is our department. So we are been providing from last 25 years to 30 years. So coming to nanotechnology. So why nanotechnology is important in pediatric dentistry? The primary focus of most of the dental specialty is a particular area of dental or a maxillofacial region. But as a pediatric dentist, we encompass a variety of disciplines, technique, and procedures and skill that shares a common basis with other specialty also. But we tend to modify we tend to adopt it on based on the requirements on the children or infant or adolescent. So these are the things which we are going to see today. Coming to the topic, first we are going to see about nanomaterials. So what is nanomaterials? So there are variety of dental materials which we use in day-to-day life. So one of the material is composite. So composite is a restorative material, or to be precise, it is a filling material. So composite is basically tooth-colored material which can be used in front teeth so that it matches the tooth color. So basically, there are big advantages of this, and there are also disadvantages of this. To overcome such disadvantages, many researchers have incorporated nanoparticles into these composites to overcome the disadvantages. Such nanoparticles are nanomorphous calcium phosphate. So by adding this nanomorphous calcium phosphate, what happened here is that there is an increase in release of calcium and phosphate. So what does calcium and phosphate release does is that it is going to increase the remineralizing property of the composite. So there won't be any secondary carries or in layman terms, there won't be any tooth decay after this restoration can be done. So the second material is that incorporating chitosan material, and they also included silver nanoparticles. So chitosan is a very good antibacterial, has a very good antibacterial properties, and also silver nanoparticles. So the basic of this and the main advantage of this is that it's going to prevent the secondary caries, or it's going to prevent the secondary decay of the tooth. The third one is quaranized polyethylenamine. So this is added to decrease the antibacterial effect or increase the antibacterial effect. And this is specially considered to have a very good antibacterial effect in various of oral pathogens, including streptococcus mutans and etc. The last one is calcium peroxide. So calcium nanoparticles has been added into the composite. So usually we use calcium peroxide in the teeth whitening treatment, but then these are a longer procedure which has to be there for 2 to 3 sittings. But then the researchers have incorporated these nanoparticles into the composite, which tends to happen that there is a constant and a small amount of release of calcium peroxide in the oral cavity, which results in tooth whitening in a day period time. Coming to nano solutions or nano adhesive, basically the composite does not bond with the tooth surface. So what we do is we have specific things such as etchant, bonding, and adhesive products which are applied to the tooth surface before we put the composite. So basically, it consists of 3 things such as etchant and bonding agent and adhesive agent. But by using nanotechnology, they have compressed it into a single solution. So this solution is in market now. It is called as Adipper, which is a single liquid which is composed of etchant, bonding, and adhesive. This can be used prior to the composite restoration. So what they have done is that they have reduced the filler particle. The filler particle is silica particle, which is spherical in shape. They have reduced these particles into 5 nanometers from the main thing. So since they have reduced the filler particles, there is the flow and the adhesiveness of these bondings are better compared to the conventional ones. And by also adding such silica particles, they have increased the shelf life of the material, and there is also good marginal seal. So good marginal seal means there is no leakage of any liquid into the respected tooth, which means we are going to prevent the secondary caries also. And there is also good stress of absorption is noticed. Coming to the third material is nano light curing glass ionomer restorative material. So what is glass ionomer restorative material? As we saw earlier, the composite was a tooth colored material and a strong material. But then a glass ionomer restorative material is the main material which we use in pediatric field because of one of the best advantage that it's going to release fluoride particles. Since they have a fluoride release particles, these are going to prevent the secondary caries. So glass ionomer restorative as a pediatric dentist we use in day-to-day life and for almost every patient. So what nanotechnology have been incorporated is that they have been added fluoroaminosilicate nanoparticles into these glass ionomer restorative materials. So because of the small structure, because of the very tiny structure of these material, they are well good and they can be polished very easily. And also when compared to composite, GIC is basically not that much of strength is there. So they can tend to have wearing of because of adjacent teeth. So by adding such material into varnish, there can be a coat which can be applied over these glass ionomer restorations, which can prevent wearing of these materials and also give a longer life compared to the normal conventional GIC. Coming to nano zirconium oxide. Zirconium oxide is a general material in a dental area with because of its natural color, and it can be incorporated into different application in dentistry. But when we come down to pediatric dentistry, the main application of these zirconium oxides are as follows. The first one is dental ceramics. So what is this dental ceramics? As we can appreciate in this picture, this is a patient who reported to our department with early childhood caries, which means tooth decay in the anterior teeth. So basically, if we do any restorations or if we do any filling, it's not going to be as much as aesthetic till we're going to put a zirconium crown, which is tooth colored and also have the same strength as the tooth. So this is one case which we have done by using the zirconium crowns. And also this zirconium oxide, which is nano zirconium oxide, can be manufactured or can be synthesized as a scaffold. And these scaffolds can be incorporated into patients of cleft lip and cleft palate. Why? Because some researchers have proved that these zirconium scaffolds have been great in enthusiasing and enhancing the osteoblast and the osteoclast activity of the bone. Thus, it increases the bone growth by using such scaffolds. So, it is very good and appreciable in using for cleft lip and cleft palate reconstruction. And also, zirconium oxide is a good radio opacity agent. So, it is also used as a radio opacifying agent. And radio opacifying agents is very important to be added in every dental material, because most of the dental materials which we use today does not have a radio opacity. So it's very good to incorporate such things. The last one is periodontal drug delivery, or in other terms, when we deal with children, the one most common trauma which we face day to day is avulsion. So avulsion is nothing but when a children or a child tend to fall down, the tooth gets moved and it comes out from the own socket. So this is called avulsion. The main treatment to be considered while doing this treatment is to re-implant the tooth in the own socket. So for doing this, there are certain complications are there. So I'll be giving you the basis about this. This is a tooth structure which has been attached to the socket by certain ligaments. So we call these ligaments as periodontal ligaments. These ligaments especially hold the tooth in their socket for a longer period of time. Since the tooth has come out and we have re-implanted, these ligaments have been stressed and it has been disturbed. So it can't be attached in the same position again. So by using triclosan, and also these tooth would have fallen down in soil, so there will be many number of bacteria and microorganisms being accumulated in this. By using nanotechnology, they have synthesized triclosan which into nanoparticles. These triclosan are believed to have a many antimicrobial effect, and it is also combined with the polymer. Why they have combined with polymer is that it will increase the absorption of these gel into the oral cavity. So for example, if we apply this gel in the gingiva of this tooth, it gets absorbed and the periodontal ligament of the tooth gets preserved. Thus, the failure rate of reimplantation of avulsed tooth can be reduced. So nanotechnology plays a very good role in this also. Coming to nano anesthesia, this is the best innovation and best invention till today, because as a pediatric dentist, we face a lot of things while giving a injection to a child. So as soon as the child sees a syringe in our hand, either the child runs out from the chair or she starts swearing at us. So basically, this innovation is very good one. So what they have done is that they have reduced the anesthetic drug products into nanoparticles. The most commonly used anesthetic drug is lignocaine or bupivacaine, which we use in day-to-day pediatric or normal dentistry as a topical anesthesia. So what they have done is they have again combined with the polymer and to make a colloidal suspension. And these nano drugs are being incorporated into nano robots, which can be controlled by the dentist or the operator outside. So why they have reduced these drug size into nanoparticle is that tooth structure has a certain communication between the inner surface of the tooth where the nerve supply is there and the outer surface of the tooth which is towards the root. So basically what happens is, since the nanoparticles have been reduced into size, they can be easily penetrate into the gum and reach certain areas where they can communicate into the tooth areas. So once they reach here, they enter the dentinal tubules. So once they enter dentinal tubules, they can directly reach to the pulp surface. So pulp is something which gives the nerve supply to the tooth. Hence, when we anesthetize the entire pulp, the tooth get anesthetized. So there is no syringe, there is no needle or anything. The patient won't get afraid of it. We have to just apply a gel over the gums region to anesthetize the local tooth, and hence we can produce an anesthetized tooth and we can proceed with the procedure. So it is a wonderful innovation by nanotechnology. Next is nanotechnology in endodontics. As far as I know, everyone in this meeting or everyone in this world, when it comes to dentists, the one treatment everyone is familiar with is root canal treatment. So what is root canal treatment without the use of nanotechnology? Yes, nanotechnology has been entered into this field, and it has been from the first step to the last step of the entire root canal procedures. So let us start with few important steps where nanotechnology has played a vital role. The first one is intracranial irrigants. So what is intracranial irrigants? There will be a lot of infection and debris which will be present inside the root surface. So this is the root surface. So we have to clean it. So there are certain irrigants which we used intercanally so that these debris get flushed out from the canals. So we use certain intracanal irrigants which has a good property such as sodium hypochlorite. So sodium hypochlorite has a variety of property and it is being ideally used. But then there are few disadvantages when it extrudes the apical region, which this is region, it causes infection again. So they have been incorporated, they have been reduced the chitosan into nanoparticles, and they have been using it as a irrigant, and they have found that these have a better enhanced bacterial degradation compared to the sodium hypochlorite, and thus it has a very good success rate compared to the sodium hypochlorite. Second one is intracanal medicament. As we see here, there is a lot of infection here. So in order to reduce this infection, oral or any intravenous injections cannot work as much as a topical drug delivery. So intracanal medicaments or topical drug delivery, which are being incorporated into the roots of the teeth, so it can be having a direct contact with infection and reduce. So the main intracanal medicament till today which we are using is calcium hydroxide, and it has been very much been useful in reducing infection. So the mechanism of action is simple, that these calcium hydroxide is going to increase the pH by releasing more number of calcium ions. So what they have done is that they have incorporated this silver nanoparticle with a size of 20 nanometers. It has been mixed with calcium hydroxide, and there are in vitro studies which have conducted in this, and they have proved that this calcium hydroxide which have mixed with silver nanoparticles have a better antibacterial effect compared to the normal calcium hydroxide itself, or when you are using chlorhexidine. So it is a wonderful intracanal medicament. And the last one which we're going to see in root canal is the obturating material. So as I told you earlier, the entire root has been cleaned and the debris have been removed. So there is a vacuum space which has been created, that and this space has to get filled. So basically, if it is not getting filled, the infection might reoccur. So the material should withstand the entire canal. So these such materials are called as obturating material. Till date, the best obturating material, or the only obturating material which we use in permanent dentition, is gattapacha. So gattapacha has its own disadvantages when it extrude or intrude. So basically, certain researchers have incorporated nanodiamond gattapacha composite embedded and with amoxicillin. Why? Because the amoxicillin has tend to have antibacterial effect, and the in vitro studies have shown that by incorporating such nanodiamond particles in the gattapacha increases the mechanical properties such as strength and elastic module. Thereby, the gattapacha has a good shelf lifetime compared to the normal gattapacha itself. So interceptive orthodontics using nanotechnology. So basically, if we take the today's generation children, they are very much concerned about their looks, and they are very much active in social medias. So most of the children which we see in clinical area, they don't tend to wear a bracket or a braces for the orthodontic treatment. They want to be something that people can't see. So nanotechnology comes to play in this also. So basically what happens is that there is a specific mechanical force which helps the tooth to move and get aligned, so that the tooth is in proper position and there is no crowding is present. So scientists and researchers have found that these mechanical force can be replaced or been supplemented by electrical force, which is around like 15 to 20 microamperes. So these are a low direct current DC currents which is been going to get applied over this alveolar bone. So these current can trigger certain molecules, and there are going to be increased activity of osteoblast, osteoclast, and periodontal ligament cells. Thus, there can be movement of the tooth on the respected aligned position. So how can we put electricity into the bone directly? It's going to hurt, right? So that's where the nanotechnology comes in play. So this system is called as biomedical nano electromechanical system. So basically, these are nanobots which can be incorporated into alveolus bone of maxilla and mandible. By incorporating such, it can move the tooth based on the alignment, because it can be controlled by the operator outside. Thus, it helps in aligning tooth, and there is no brackets and braces should be worn. So the patient also will be happy that there is no brackets, and he can still upload selfies in Instagram to be looking smart. So next one comes is nanolipus device. Nanolipus device is nothing but a device which uses ultrasound. And this is one of the greatest device which can be used in the developmental process. As we can see in this child, her profile is convex and her profile is concave. So basically, if there is a normal children, if the profile has to be straight in order that they don't need any orthodontic correction and the bone development has occurred correctly. But if we take the case A, it has been convex, which means the lower jaw or the mandible has not been grown properly to the sides. So by using this nanolipus technology, which is low impulse ultrasound technology, it can induce bone growth of mandible, and it can be controlled. So we can control how much bone growth is needed. By doing this, there can be proper growth in mandible. So this girl or this children or this patient is going to have a proper profile in the future. So this we are intercepting in the early stage, so that when the child enters the adolescent age, will have a good facial profile. And the second one is, again, here we can see that the lower jaw has been grown properly, but then the upper jaw is not grown properly. So in the same cases, we can use this device to increase the growth of the upper jaw. Thereby, we can treat and correct the patient before entering the adolescent period. The last one is the preventive dentistry. So as a pediatric dentist, we don't not only treat the patient, but also we prevent certain diseases from the children, especially caries. So caries is the one main thing which we have to prevent from the children in order to have a oral healthy life for the entire thing. So basically what happens is that toothbrush and toothpaste and mouth rinses, all these products have been incorporated with the certain nanoparticles such as chitosan or hydroxyapatite crystals or carbonate nanoparticles or silver nanoparticles or silver gold particles. So basically all these particles have a good number of antibacterial effect on oral pathogens, especially mainly the caries forming pathogens such as Streptococcus mutans and etc. These are going to reduce such oral pathogens in the oral cavity. Thus, it prevents the caries formation in the childhood and also adolescence. So it is well appreciated in preventive dentistry also. Hence, to conclude that there is a great responsibility to ensure the safety and efficacy and applicability of such new technologies. But there is science behind nanotechnology is still developing, and there is a lack of long-term clinical evidence addressing their clinical performance restricts their wide clinical use. Thank you.
Thank you, Dr. Sibikar. I genuinely appreciate your review article. It's a wonderful presentation. So now the platform is open for questions. Anyone want to ask any questions? So they can. Okay. Dr. Shibikar, again, thank you.
Yes, ma'am. Thank you.
Our next speaker is Dr. Gayatri VS.
Good morning.
Dr. Gayatri VS.
Good morning, ma'am.
Okay. Okay. Good morning. She is from Faculty of Dental Sciences, Rama University of Applied Sciences, Bangalore, Karnataka. Her topic is management of dental caries using nanohydroxyapatite. It's also a review article. So, doctor, please proceed.
Thank you, ma'am. Good morning to one and all present here. The topic that I will be talking about is management of dental caries using nanohydroxyapatite. So I am starting my presentation with a very scary image of this human skeleton. This is to make you understand what exactly hydroxyapatite is and why is it so useful for us. So what do you see here? You see bones and you see teeth. So hydroxyapatite form major constituents of the bones and the teeth. So the teeth have hard mineralized structures called as the enamel and the dentine. And the hydroxyapatite forms a major constituent of enamel and dentine as well. So in case of bones, the 70% of bones is hydroxyapatite. And for teeth, like I said, the outermost layer of the teeth is called as the enamel. It is the hardest tissue, mineralized tissue of the body. It has 96% of the inorganic constituent. And dentine, this is the second layer. It has 70% of the inorganic constituent. And both are nothing but hydroxyapatite. So basically, there are two components. That is, you have the organic component, which is, in case of bone, it is the type 1 collagen. And in case of enamel, it is the enamel proteins like the amelogenin, enamelin, etc. Then you have the inorganic component, which is the hydroxyapatite. So these two components, they form a composite structure at the nanoscale in which the hydroxyapatite particles are interspersed in the organic matrix. With this whole composite structure, it forms the precursor for mineralized tissues like tendons to hard tissues like bones and teeth. So a little bit about on the chemical level of the hydroxyapatite. So it is a calcium phosphate or a calcium apatite compound. It's a naturally occurring form of the calcium apatite, and it has a typical apatite lattice structure. So the chemical formula of hydroxyapatite is Ca10PO46OH2. Pure hydroxyapatite contains about 39.68 weight percentage of calcium and 18 weight percentage of phosphorus. 18% weight percentage of phosphorus. So it has a calcium phosphate ratio of 10/6, that is 1.67. Now, why are we talking about nano here? This is because nanoscale, like it has been explained, it ranges from 1 to 100 nanometers. Okay, and so synthetic nanohydroxyapatite, they have found their niche in the medical and the dental field starting from about 1950s. The nanoscale, as it ranges from 1 to 100 nanometer, because of these dimensions, these small dimensions, they have distinct properties and activities. So they have a large reaction surface and a small size, due to which they have better and superior chemical and physical characteristics. So they're also similar. The nanohydroxyapatite. They're also similar to the apatite crystals of the tooth enamel. So their similarities are in terms of morphology, their crystallinity, biocompatibility, and also bioactivity. A little bit about the synthesis of nanohydroxyapatite. So there are various methods like sol gel method, precipitation method, solid state method, hydrothermal reaction, sonochemical reaction, etc. But the wet precipitation method is the most commonly used method. This is because the wet precipitation method forms a non-stoichiometric. It is easy to easy to operate, and it can be operated at a very low cost. But it forms non-stoichiometric hydroxyapatite nanoparticles, which means that it has a lot of impurities in it, like sodium, carbonate, chloride, etc. So this might lead to forming calcium deficient hydroxyapatite. Nevertheless, because of its ease of operation, this is the most commonly used. But solid state method, this will help in forming stoichiometric hydroxyapatite nanoparticles. Yet it requires very high temperatures. That's about 1250 degrees Celsius of temperature. But the disadvantage of this is that there might be heterogeneity in the phase composition. And prolonged heat treatment, it can cause an increase in the crystalline size. So if there is an increase in the crystalline size, there will be decrease in porosity. Now, like I said, because of the nanoparticles because of their size, they have better properties. They have better bioactivity, so due to which they have properties like osteoconductivity and osteoinductivity. So because of these properties, they have been widely used in bone tissue engineering, tissue regeneration as a replacement for bones, as a replacement for bones as well. So in implantology, they have been these nanohydroxyapatite have been used as a coating around the implant. So because, like I explained, because of its high bioactivity, it can form better bonding with the bones and also help in genesis, new bone genesis. Also, hydroxyapatite is a modulator for your monocytes and macrophages, which are the inflammatory cells. These can also regulate inflammation. Next is its use in managing dentinal hypersensitivity. So you would have encountered this when you're eating something very cold or very hot or something sweet. Suddenly there's a sharp shooting sensitivity, or you feel like it's pain. So this is called as dentinal hypersensitivity. So basically, what happens is whenever there is erosion of the outer layer of the surface, or erosion of the outer layer, the dentinal tubules are exposed. So when the dentinal tubules are exposed, there's fluid inside the dentinal tubules, and any stimulation, like any tactile stimulation of this, can lead to the movement of the fluid, and this fluid can then activate the receptors of the pulp. The pulp is the innermost part of the tooth. The pulp is the living tissue of the tooth. It has got all the nerves and blood vessels. So when the nerves are stimulated, you get sharp shooting pain. So what this nanohydroxyapatite does is it because of its size, it can easily penetrate the dentinal tubules. And nanohydroxyapatite is a reservoir for calcium and phosphate. So they help in mineralization, and they block these dentinal tubules. So there is no movement of the fluids. Okay, that is how it manages dentinal hypersensitivity. And next is management of early enamel caries. I'll be explaining that in the further slides. So to understand how it manages dental caries, we need to understand the mechanism of action of dental caries. So basically, your tooth, the dental caries, it's an infectious disease which is characterized by two things. That is the destruction of the organic matter and dissolution of the inorganic matter, often leading to cavitation. So the tooth is always going through two processes, remineralization and demineralization. That is the calcium and phosphate coming in and out of the tooth. So this has to be always in an equilibrium or always in a balance. Now, when this balance shifts to demineralization is when dissolution occurs. So when does it shift? It shifts when you have these the case triad, that is the tooth, the host quality, the carbohydrates. You have an increased consumption of carbohydrates, increased frequency of consumption of carbohydrates, and you don't maintain your oral hygiene. There will be bacteria in the mouth, especially the Streptococcus mutans. So all these, the bacteria will then act upon the carbohydrates, and then there is production of acid, and this acid will reduce the pH. Now there's something called as a critical pH, which is 5.5. When the pH falls below this, is when dissolution or demineralization happens. So when there is demineralization, there is when there's demineralization, there is loss of the minerals, that is the calcium and the phosphate, which leads to dental caries. So the management of dental caries, it was usually invasive. So whatever caries it might be an initial enamel caries, a white spot lesion, that is just the starting of the caries, or a frank cavitation. You would just excavate the caries and you would replace the tooth structure with artificial materials. But why go for artificial when you can actually revive your natural tooth? That is by using remineralizing agents. Fluorides have been used as remineralizing agents. It's widely used as remineralizing agents. You have fluorides in your toothpaste. You have water fluoridation. You can also apply it as gels and varnishes. But the problem with fluoride is that chronic ingestion of this mineral can lead to a condition called as fluorosis. It's a very damaging condition, and hence we need to find new remineralizing agents that can replace fluoride or at least act synergistically with fluoride to increase the remineralizing capabilities. So that is how we come to nanohydroxyapatite. Now, how does nanohydroxyapatite help in remineralization? So like I said, the nanohydroxyapatite is similar to the natural tooth apatite crystals. Okay, and then they have, because of their size, they have high surface area. And this high surface area will provide good mechanical strength and also good absorption. So because of this, they get absorbed strongly onto the enamel surfaces and the enamel rods. This is because the absorption process increases with decrease in particle size. So when there is an incipient enamel lesion or the initial carious lesion, the surface of the enamel of that region, it becomes porous. So because of this porosity, there is greater penetration of the nanohydroxyapatite into the enamel surface. So once it gets penetrated into the enamel surface, it acts as a reservoir for calcium and phosphate. And also it acts as a template and continues to attract calcium and phosphate ions onto the enamel surface. So in this way, it will promote the growth of the crystals and also the crystal integrity. So concentration of 10% is said to be usually effective for remineralization process. It is said that as the concentration increases, remineralization also increases. But if that is the case, then as we keep increasing the concentration, then the tooth should, remineralization should occur on the tooth and the tooth should become a bulbous, a huge structure. But why is that not happening? That's because we don't see much significant, much increase in the remineralization when we increase the concentration more than 10%. Which means that if I increase the concentration of nanohydroxyapatite from 5% to 10%, a significant increase in remineralization is seen. But more than 10%, not a significant difference is seen. Now, this is because when we remineralize, what happens is the outer enamel layer, the pores of the outer enamel layer, they are the nanohydroxyapatite penetrates onto the pores and they form new apatite and they a new apatite and they block the pores. So further entry of the nanohydroxyapatite is stopped there. So the deposition now comes to a stable level. So here we spoke about the remineralization capabilities. Next is the inhibitory effect that the nanohydroxyapatite has. So the Streptococcus mutans, these are the primary causative organisms for caries. So when we eat carbohydrates, that's sucrose, glucans are synthesized by glucoside transferase or by the action of glucoside transferase enzyme. And these glucans, they help in the adhesion of these Streptococcus mutants. And also, once they adhere onto the glucans and onto the teeth, there is expression of virulence. Now, again, nanohydroxyapatite, because they have good adsorption properties, they get adhered onto the glucans and the salivary proteins. Thus, they will not allow the streptococcus mutants to get adhered, or they will prevent the colonization of these streptococcus mutants. So they are not the cardiogenic properties or cardiogenic activity of S mutants is inhibited there. Next, about the synergistic effect with fluoride. So when nanohydroxyapatite is added to mouthwash or dentifrices that contain fluoride like for example sodium fluoride, they have a synergistic effect. That is, they add to the effect of fluoride. So what happens is they react with the sodium fluoride and they form fluorapatite and sodium hydroxide. Now sodium hydroxide being a base, it increases the pH. Now as the pH is increased, there is no question of demineralization. So because of all these properties, they have been incorporated in dentifrices. Like toothpaste, Elamint toothpaste is a nanohydroxyapatite toothpaste. Then mouthwash in pit and fissure sealants, and also in restorative materials like resin modified GIC. This will increase the remineralization properties of these materials. Now, so many advantages of having small size, but also there can be disadvantages of having this small size. This is because due to the small size, they can enter the human skin, the lungs, and also the circulatory system and the lymphatic system easily. And they can also penetrate the cells of the human being. So after they penetrate, because of their good and superior reactivity, they react with the oxygen molecules and they produce free radicals or reactive oxygen species. These reactive, like you have superoxide and peroxides, when these reactive oxygen species are produced, they damage the cells by damaging the mitochondrial membrane, and this will cause an irreversible damage to the cell, or something called as the cell death or apoptosis. So this depends upon the size, shape, concentration, and exposure time. This toxicity levels. And it is seen that needle-shaped nanohydroxyapatite is the most toxic, but in oral care products, we use rod-shaped nanohydroxyapatite. Also, the Scientific Committee on Consumer Safety, they could not draw any conclusion on the safety of these particles, as very little scientific literature is there that confirms the toxicity of these nanohydroxyapatite particles. So to conclude, nanohydroxyapatite is a promising material in the field of dentistry. Due to its superior physical and chemical properties and similarities to the dental hard tissues, these can be helpful in managing various dental problems like dentinal hypersensitivity, initial dental caries, etc. Also, it can have useful effect in preventing dental caries by inhibiting the activity of microorganisms responsible for dental caries. Now we need to evaluate the long-term effect of these nanohydroxyapatite and also the cytotoxicity of nanohydroxyapatite in the future research. These are my references. Thank you so much, and I would like to extend my gratitude to my guide, Dr. Pushpalata. Thank you.
Thank you, Dr. Gayatri. Your lecture is very demonstrative and informative. Thank you for a great presentation. So the platform is open for questions. Anyone want to ask any questions? They can.
Dr. Gayatri.
Yes, sir.
Yeah, very interesting topic, and your explanation is very details. And thank you so much for your presentation. And thanks to support us for this conference. Thank you so much. Good luck.
Thank you so much, sir. Thank you so much.
Our next speaker is Dr. B. Joan Manga-Delin. B. Joan Manga-Delin. Are you there?
Yes, ma'am. Good morning, ma'am.
Okay. Good morning. She is from Department of Chemistry, Holy Cross College, Nagarkoli. Her topic is encapsulation of doxorubicin on silica nano-assembled capsules and controlled drug delivery. Dr. B. Joan, you can proceed.
Yes, ma'am.
Please share your slides.
Can you able to see my screen?
Yeah, it's visible.
Good morning. I'm Joan Magdalene from the state of Tamil Nadu, India. And I'm a research scholar and I'm doing research under the guidance of Dr. S. Ajit Sindhuja. Topic which I'm going to present is the encapsulation of doxorubicin on hollow silica nanoassembled capsules and controlled drug delivery. So the content of my talk will be based on the scope of my work, introduction, experimental section, results and discussion, and the conclusion. So the scope of my work is hollow silica capsule structures are ideally suitable for drug delivery as they can be made highly porous, allowing for efficient diffusion and uptake of drug molecules. And the approach here is to synthesize submicron-sized hierarchically ordered silica nanoassembled capsules under hydrothermal conditions using beta-cyclodextrin and colloidal silica nanoparticles. And silica dioxide nanoassembled capsules will be used to encapsulate an anti-cancer drug, that is doxorubicin, with high loading capacity and controlled delivery. So this can be an attractive strategy for the design of smart delivery vehicle and may be used for in vivo drug delivery vehicle in wider spectrum of therapeutics effective within cancer biodiversity. So introduction. Silica nanoparticles assembled hollow silica nanoassembled capsules are a prominent class of hybrid capsules which are synthesized by various methods such as layer by layer assembly of polymers and nanoparticles, block cope polypeptide mediated assembly of nanoparticles, and polyamine salt mediated assembly. When compared to conventional hollow silica capsules, silica dioxide nanoassembled capsules have several advantageous features such as low density, high surface area, ease of functionalization, low toxicity, and good biocompatibility. Owing to these favorable properties, it can serve as an efficient drug delivery vehicle. Among the various mesoporous silica materials, this hollow mesoporous silica spheres are also called as silica capsules are expected to show increasing therapeutic efficiency because of their unique core shell structure, which affords a high surface to volume ratio and short mass transport distance. So this figure represents the 10th image of mesoporous silica nanoparticles, and second B, the figure B is the hollow mesoporous silica nanoparticles. So the inner hollow core can be loaded with diverse cargoes or act as a confined space. So here the key purpose is to serve as the shell region to encapsulate the drug. Its key purpose is to serve as a physical barrier to control the diffuse release of drug. The next is the doxorubicin. I have chosen the doxorubicin as my drug delivery for my drug delivery studies. So this doxorubicin hydrochloride is a well-known androquinone anti-cancer drug which is effective against various human malignancies, including various types of cancer, including hematological malignancies and many types of carcinoma and soft tissue carcinomas. And it is often used in combination of chemotherapy. And it is not only toxic to cancerous cells, but also toxic to normal cells, creating serious side effects because of non-specific cell tissue biodistribution. Hence, this doxorubicin encapsulation has emerged as a promising strategy to reduce its side effects and control the release of this doxorubicin. Now, moving on to my experimental section. First, I have synthesized the silica dioxide nanoparticles assembled capsule. First, I have taken 5 ml of silica dioxide nanoparticle, which is purified by membrane dialysis against ultra pure water for 48 hours and mixed well with a solution of beta-cyclodextrin in 5 ml of water. And the resultant solution was transferred into a Teflon-lined stainless steel autoclave, which is sealed and heated to 200 degrees Celsius for 10 hours. And after the completion of reaction, a dark brown precipitate containing the core shell microspheres was collected by centrifugation till 15 minutes I have done the centrifugation. And finally, the core shell microspheres were washed with water and dried in vacuum, followed by calcination at 650 degrees Celsius for 5 hours to get the colorless silica dioxide nano-assembled capsule in pure form. And next, the incorporation of this drug into the silica dioxide nano-assembled capsule. So I have chosen doxorubicin as my drug. So an aqueous doxorubicin solution, 10 milligram in 5 ml, was stirred with 10 milligram of silica dioxide nano-assembled capsule and stirred at room temperature. After 24 hours, the dox-loaded silica dioxide nano-assembled capsule were separated by centrifugation, and the observed amount of this dox was estimated by UV, which is characterized by UV absorption spectroscopy, and I have calculated the encapsulation efficiency also by using the formula. So the X refers to the concentration of dox. Dox means doxorubicin. So X, the formula is X initial minus X final divided by X initial into 100. And next is the dox release experiment. So the release of dox from dox-loaded silica dioxide nano-assembled capsule was evaluated using a semi-permeable dialysis bag diffusion technique right after the dox loading. And the dialysis membrane was activated by boiling with deionized water and washed several times with phosphate buffer solution of pH 7.4. And the as prepared dox-loaded silica dioxide nano-assembled capsule containing 5 milligram was dispersed in this phosphate buffer solution of 5 ml at pH values, at 2 different pH values. One is pH 7.4 and another one is pH 5. So the release media was placed into pre-treated semi-permeable dialysis bag, and then it is immersed into 20 ml of phosphate buffer solution at 37 degrees Celsius with gentle stirring. At regular time interval, this 2 ml aliquots are withdrawn from the phosphate buffer solution, and the released dox was measured by UV spectroscopy, which I am getting at the peak I will be getting at 482 nanometer. So moving on to my result and discussion. First, I have synthesized and characterized the silica dioxide nano-assembled capsule. So my methodology is to fabricate this silica dioxide nano-assembled capsule and to encapsulate the anti-cancer drug into this silica dioxide nano-assembled capsule. So this is the schematic route for the preparation of this dox, a loaded silica dioxide nano-assembled by the self-assembly of silica dioxide nanoparticles under hydrothermal conditions using beta cyclodextrin, which hydrothermal reactions comes under the bottom down approach. So first is a preformed stable dispersion of beta cyclodextrin and colloidal silica dioxide nanoparticles were prepared under hydrothermal conditions for 200 degrees Celsius for 10 hours, and then subsequent dehydration, polymerization and carbonization followed by the assembly of silica dioxide nanoparticles are formed with carbon-based silica dioxide. Then to encapsulate this dox, a simple mixing of both the component in water medium at 24 hours, we afforded the dox encapsulated silica dioxide nano-assembled capsule. Initially, I first attempted the hydrothermal carbonization at 160 degrees Celsius to afford this carbon nanospheres, but I have failed to afford. So my next attempt was to increase the temperature. So I increased by 200 degrees Celsius. At that time, the hydrothermal temperature and condition was changed, which had resulted in a black solid of carbon nanospheres. With lesser time, 6 hours also, the same results were obtained in both alpha and beta cyclodextrin. And then is the characterization technique, which is the FTIR. So the FTIR spectroscope, this is the figure of the FTIR spectrum of carbon nanospheres, which is A and B refers to the alpha cyclodextrin at 6 hours and 12 hours, and C and D is the beta cyclodextrin at 6 hours and 12 hours. So this FTIR spectra of synthesized carbon materials show band at 1737, 1610, 2970 corresponds to the C double bond O, C double bond C and CH stretching for carbon spheres. And the band at 3440, 1215 are due to the OH and CO stretching vibrations, implying the existence of large number of residual hydroxyl groups which impart hydrophilicity to the surface of carbon spheres. And next is the SEM analysis. So the spherical morphology and 500 nanometer size of the synthesized carbon nanospheres was confirmed by the SEM analysis of for both alpha and beta cyclodextrins. A and B is alpha cyclodextrin at 200 degrees Celsius for 6 hours and 12 hours. And the figure C and D is beta cyclodextrin at 200 degrees Celsius for 6 hours and 12 hours. So further continuing the reaction time to 12 hours also, the spherical morphology and size of carbon materials are retained, indicating that there is no structural and morphological change, which is evidenced by the SEM analysis. And the synthesis of silica dioxide nano-assembled capsule templated from a carbon core formed from beta cyclodextrin by hydrothermal method, which shows that the cyclodextrin dehydrates, polymerizes, and carbonizes into carbon spheres, and negatively charged silica dioxide nanoparticle deposits around the spheres to form a multi-layered thick shell. So the resulting organic or inorganic hybrid microsphere contain carbon in the core interior and silica dioxide nanoparticle as the exterior shell. So removal of this carbon core by simple calcination results in the silica dioxide nano-assembled capsules with porosity. These two are the SEM and TEM image of carbon spheres and carbon-based silica dioxide nanocapsules. So the SEM and TEM image reveals the spherical morphology with size of 500 nanometer and assembly of silica dioxide nanoparticle in as-formed carbon spheres. And the hollow silica dioxide nano assembled capsule obtained by the removal of carbon core matrix by calcination still possess the spherical morphology, which is revealed by SEM and TEM. This C and F shows the spherical shape of carbon core matrix. So the calcination did not cause any morphological change in silica dioxide nano-assembled capsules. The STEM image clearly reveals that the hollow nature of robust silica dioxide nano-assembled capsule with a shell thickness of 150 to 200 nanometer, and the silica dioxide nano-assembled capsules are of size 500 to 700 nanometer as that of carbon-based silica dioxide nano-assembled capsule. Next is the encapsulation efficiency. So encapsulation efficiency, after the complete characterization of the hollow silica nano-assembled capsule, the drug loading capacity and controlled release behavior of the silica dioxide nano-assembled capsule with the DOX, that is an anti-cancer drug, which is selected as a model drug, was evaluated. Before encapsulation of DOX, the silica dioxide nano-assembled capsules are preheated at 120 degrees Celsius for 5 hours to remove the moisture. And then the DOX solution and the dispersed solution are mixed together and stirred constantly at room temperature. After 24 hours of agitation, this DOX is found to be completely loaded on silica dioxide nano-assembled capsule, which is evident from the color change from colorless to pink. And the loading efficiency of encapsulated DOX reaches 86%, and the drug loading capacity of 8.6 milligram of DOX per milligram of silica dioxide nano-assembled capsule support, which is determined by this characterization absorption peak at 486 nanometer. And here the black color, that is the figure A, that represents the initial DOX, and the red color is the final DOX, and insert photographs of the A refers to the DOX solution, and B is the silica dioxide nano-assembled capsule, and C is the DOX loaded silica dioxide nano-assembled capsule. And next is the in vitro controlled release of DOX from the silica dioxide nano-assembled capsules. So this in vitro controlled release of DOX is evaluated by dialysis method, and the as prepared DOX loaded, that is 5 milligram or dispersed in 5 ml of PBS solution, that is phosphate buffer solution. And the release media was placed into pre-treated semi-permeable dialysis bag and then immersed into 20 ml of phosphate buffer solution at different pH I have noted. First, I have heated from 6 hours to 72 hours, then at a pH 7.4, and second graph is at a pH 5. So the resulting mixture is stirred slowly, and the release of DOX was measured by UV visible absorption spectra by monitoring the absorption intensity variations, which is at 482 nanometer. And the release kinetic was also monitored up to 72 hours and at pH 7.4. And the release was observed as 36% in this area. And when studied at pH 5, the DOX release is slightly enhanced when compared to the pH 7.4, showing 44% of DOX release after 72 hours. And it is calculated using the absorption spectroscopy at 482 nanometer. And the percentage of DOX release is also calculated by comparing both the pH values at 7.4 and 7.5. So as there is an equilibrium between DOX loaded on silica dioxide and the DOX in phosphate buffer solution with an increase in release, the release rate is also slowing down, and hence the release profile does not follow a straight line. It is worth to mention to know that even though the release rate is slow during a longer period, it does not reach a plateau. So when the DOX released from silica dioxide nanoassembled capsule at pH 7.4 and 5 are compared, a small but significant increase in the release percentage from 36% at pH 7.4 to 45% at pH 5 is observed. So this phenomenon of drug release might be attributed to the protonation of amino group in DOX molecule at lower pH, which renders the enhanced hydrophilicity and higher solubility to DOX, minimizing the hydrogen bonding interaction between the DOX and the silica dioxide nanoassembly capsule, and hence a pH is dependent enhancement in the release profile of DOX at lower pH value. And this is the schematic, the overall work which I have done. That is silica dioxide nanoassembly capsule, which I am encapsulated in DOX, and then the controlled release of DOX was calculated by the encapsulation efficiency, and these are the graphs. And moving on to my conclusion part, a facile methodology to fabricate the hierarchically ordered silica nanoassembled capsules with porosity is developed by combining the hydrothermal carbonization of beta-cyclodextrin with self-assembly of colloidal silica nanoparticles. And this controlled self-assembly of silica dioxide nanoparticles during a hydrothermal process enables the formation of co-shell hybrid spheres of carbon and silica dioxide nanoparticle, and the removal of carbon, which is characterized extensively by SEM and TEM and FTIR studies. And the synthesized silica dioxide nanoparticles have accessible surface area, that is porosity, low density, and it can accommodate DOX, an anti-cancer drug, for controlled drug delivery studies. And beta-cyclodextrin is used for the first time as a template for the formation of carbon spheres with uniform size and morphology under hydrothermal conditions, and which is used to encapsulate an anti-cancer drug, which is doxorubicin, for controlled drug delivery study with high drug loading capacity, that is 8.6 milligram bar 10 milligram. And the DOX release from silica dioxide nanoassembled capsule is highly controlled and progressive with 36% of drug release in 3 days. So I'm further on studying with the cytotoxic activity also, but I didn't get characterization techniques, so I'm not included. So if we are doing the cytotoxic study also by MTT assay, we can say how it is having low toxicity and all. So toxicity study is on further progress. Thank you.
Okay. Thank you, Dr. B. Joan, for your wonderful lecture, and we get information about your review article. Okay. Now, I would like to say Dr. Thinkaran.
Yes, thanks, Dr. Nidhi. Dr. John, are you there? Yes, are you there?
Yes, sir. Yes, sir. Good morning, sir.
Yeah, good afternoon. Dr. John, yeah, can you share your slide again?
Okay. Yes, sir.
Yeah, can move to encapsulation efficiency slides.
Okay, sir.
Yeah, this one, I think if not missed, you have to mention about 120 degrees Celsius. Is it your temperature?
What's your encapsulation efficiency?
Yeah, it's your temperature 120 degrees.
120 degrees Celsius for 5 hours. Remove the moisture content.
Yeah. Did you have tried with the variable temperature?
No, sir. For silica dioxide nanoparticles, I have done for 150 Celsius and 200 degrees Celsius. But in 160 Celsius, I didn't get. 200 degrees Celsius, I offered the carbon nanoparticle. But here, I tried at 120 degrees Celsius.
I see. Okay, okay, Doctor. Dr. John, thank you so much.
Thank
And
you.
yeah, it's, your presentation is very good. Thank you so much.
Thank you, sir.
And next, we move to Dr. Puspalata. Dr. Puspalata, are you there?
Yes, sir. I'm here.
Okay, doctor. So you are the last presenter for our morning session. Okay. So Dr. Puspalata is our keynote lecturer. She from India, from Ramaya University, and she going to talk about theobromine nanoparticle in the prevention of dental caries and vitro study. So we can start, ma'am. Thank you so much.
Okay, sir. Thank you, sir. Sir, I'm not able to
Hi everybody, my name is Ken and I'm the director of Angkasa Quarries Plastic Sandaran Art. Our company is a recycling company and we have started up the company around 4 years ago. But prior to that, I have 25 years of experience in the area of plastic recycling. Right now, our company main processing is doing recycling of plastic waste. The company, which is short form, the acronym is ANCOP, Angkasa Quarries Plastic Sandaran Berhad. We have full compliance from the government, from the ISO 14001. We have a compliance in the Department of Environment. We have compliance with the municipal government bodies of Malaysian government. Our main job is not only to make money, but obviously it's part of it, but then it's also to help the country to develop to a state where we are able to bring in processed waste material to reduce the waste that is dumped in the country and help out with whatever we can do. Even in the area of landfill, we are extracting plastic waste, we convert it into usable plastic. We hope that this program will work well. At the same time, what we have been doing is work with the various colleges and universities in Malaysia to bring them the knowledge and equip them with a better knowledge of recycling. And in time to come, we hope in the next few years with this program and the courses run by our company, students will be well trained and be more cautious about our environment. We hope that the government of Malaysia will continue to support us on the long term, and the staff in ANCOP, they are all very hardworking, and we feel that we still have a long way to go to achieve our goal. We appreciate that whoever that's looking into this.
Everyone, I'm Dr. Pushpalata, an associate professor from Department of Pediatric and Preventive Dentistry, Faculty of Dental Sciences, Ramaiah University of Applied Sciences, India. I thank the organizing committee of International Summits and Conference on Biomaterial Science, Nanotechnology and Biomanufacturing 2021 to give me an opportunity to share my research work on theobromine nanoparticles in the prevention of dental caries and in vitro study. I think everyone loves chocolate here, whether you're an adult or a child, no matter what is your age group. So you can never resist eating a chocolate, which is considered to be a heavenly sweet. The sight of the chocolate itself is very tempting and mouth-watering. But you know that there is a myth behind this chocolate. Everyone says that chocolate is cariogenic. Don't eat chocolate. Stop eating. It is harmful for teeth. But actually speaking, the chocolate is not cariogenic. The coca, which is considered as a food of God in Latin, it's a main ingredient of the chocolate. When it gets mixed with the sugar, makes the chocolate cariogenic and leads to the formation of dental caries. So the present study also shows that the coca, the main ingredient of the chocolate, is not cariogenic, but you can use to prevent the dental caries formation. So to eliminate the dental caries the organisms, the microorganism that causes the dental caries, and to promote remineralization of the tooth. Presently, we have variety of drug delivery system in the market, like solutions we have, rinses, gels, toothpaste, fluoride varnishes. Among all these drug delivery systems that are available in the market, the dental varnish, that is a fluoride varnish, is found to be more effective in prevention of dental caries. And it is very effective in children with high risk individuals also. So why it is effective? Because it has got a lot of benefits, like it provides prolonged drug availability, better penetration of the drug into the tooth structure, high concentration of the drug at the site of action, and it provides increased adherence to the tooth surface. And it also can be used in a children where you can see lot of saliva flow. Means usually in children there will be a flow of the saliva compared to the adult. So in that cases, you can use this fluoride varnish. But there is, in spite of all these advantages, you can see lot of drawbacks. Like you can see toxicity. That is, we call it as fluoride toxicity. And bacterial resistance, it's more commonly seen presently. And even the patients will come up with vomiting, diarrhea, the main chief complaint with use of these things. And even the patients report with tooth discoloration, and even the complaint of chronic.
Excuse me, ma'am.
Yes, sir.
Your slide is not moving, ma'am.
How, sir?
Your slide is not moving.
So
yeah, now can move. Yeah.
So can I keep it like this only, sir?
Yeah. Sure.
Okay. So as I've mentioned, it has lot of the fluoride varnish, which has got lot of drawbacks associated with it. So even we can see chronic irritation of the gingiva on application of this fluoride varnish. So recently, what has happened? So the interest have moved towards the natural products. I've gained interest in the caries prevention. Like we started using cranberries, grape seed, then we are using onion, green tea, then turmeric, honey, coffee. All this we have started using. So which has got mainly the antibacterial property, and which is considered to be safe, non-toxic, and they are rich in bioactive compounds. So mainly it acts as a antibacterial action, basically by inhibiting the enzyme dextrosucrase, which is the key enzyme that is necessary for the dental caries formation. And it also reduces the biofilm formation and reduced acid production. So, but all this natural products which I mentioned, it has only the antibacterial activity. It lacks the remineralization potential. So recently, it has we have found that like the coca, which is, as I mentioned, which is a food of God or in Latin, has got both remineralizing and antibacterial activity, and which is a rich source of fat, carbohydrate, proteins, polyphenols, minerals, methylxanthine, etc. So the coca polyphenols that is present in the coca, it has antibacterial activity mainly by inhibiting the enzyme dextrosucrase, what I've spoken before, and even it has inhibits the biofilm formation and acid production. Whereas the theobromine that is present in the coca exhibits a remineralization potential, mainly by increasing the enamel hardness. It increases the enamel hardness by depositing calcium and phosphorus on the enamel surface, and it has a capacity to increase the crystallinity of the enamel, and even the size of the crystal that is formed it's large compared to that of a standard sodium fluoride varnish, and the crystal size, it is about 7 times larger than that of a sodium fluoride. If you have a large size crystals, it means that the tooth is very resistant to acid attack, and it is very strong. So there is less prone for caries. So based on this background, we went for a formulation of a theobromine nanoparticle based dental varnish, and its effect on remineralization of enamel carious lesion also assessed. So in order to achieve the aim of what I mentioned, the methodology was like this, as I've shown in this one. First, the coca beans were collected from Puttur, that is a Mangalore district in India, and the coca beans were sorted. It was separated and it was cleaned. The flat and the broken coca beans were removed, and the selected coca beans were subjected to grinding using an electric grinder. After that, the coca bean powder, what we have obtained, was dried using a oven at 40 degrees for 4 hours. The dried coca powder was sieved through a sieve size of 120. After that, this coca powder was subjected for defatting procedure. So we wanted to remove the lipids, wax, and pigments. So we wanted basically the important ingredient, that is polyphenols and the theobromine in the coca extract. So we wanted to remove the unwanted lipids, fats and all. So after 7 days of defatting procedure, the defatted sample, this you can see the black powder, that is a defatted powder, was subjected for Soxhlet extraction procedure. So this Soxhlet extraction procedure, we use a Soxhlet extraction method. We did for 3 days. After 3 days, the residue, we've obtained a residue, we can see in the bottle, that residue was obtained and it was concentrated. It was heated on a water bath so that we get a concentrated coca extract. So after obtaining the concentrated coca extract, we wanted to confirm that coca extract contained a theobromine or not. So we did a HPLC analysis was done. So the HPLC profile of the coca extract correlated with that of a standard theobromine. Here you can see in the graph, here the two peaks were correlating. This correlation showed that the coca extract contained the theobromine. After confirming that it has theobromine, then we went for isolation of the theobromine particles. So in order to isolate, we used preparatory HPLC. So this one, after subjecting to the isolation, we obtained a white amorphous powder, that is as is shown in the image. And we wanted to confirm whether the isolated compound is really theobromine or not. So we did structure determination of the isolated compound. We did UV spectrometer, FTIR, mass spectra, and NMR. So the peaks of these data were correlating with the standard peaks. So this suggested that the isolated compound, what we isolated, was theobromine. So after confirming that isolated compound is theobromine, we prepared the nanoparticles of theobromine using a probe sonication method. To confirm whether it is really a nanoparticles and what is the size of the nanoparticles, we did the SEM analysis. So the SEM analysis showed that the particle size of the theobromine was 50 to 60 nanometer. So after this, we went for the formulation. Before formulating, we wanted to see whether the isolated compound is toxic or not. So we did a cytotoxicity assessment using MTTA assay. So we used a different concentration of the compound, like varying from 6.25, 12.5, 25, 50, 100, and 200. At a lower concentration of 6.25 milligram, we could see just only 1.8% of the cells were inhibited. At the highest concentration of 200 milligram, we found 90% of the cells were inhibited. So the results showed that the isolated compound is less toxic, safe, and can be used in the formulation safely. And so we fixed the concentration of the theobromine below 6%. And we wanted to know whether the isolated compound has got an antibacterial activity or not. So for this, we went for an in silico approach. That is, we did a molecular docking of the isolated compound. We selected 4 molecular targets of Streptococcus mutans. That is, we selected human superoxide, dismutase, glucan, sucrase. Then we used Streptococcus mutans sortase A and streptococcal surface adhesive. Only 4 targets were identified, and which were the main targets for the formation of dental caries. After docking, we found that the docking results showed that human superoxide dismutase had a binding affinity with the theobromine nanoparticles. So with a binding score of minus 3.89, whereas a glucan sucrase also had a binding affinity for the Streptococcus mutans with a binding score of minus 4.03. And after seeing the results for Streptococcus mutans sortes A, which had a binding score of minus 4.06, and with Streptococcal surface adhesine, the binding score was minus 5.0. So all these results of the in silico approach showed that theobromine has an antibacterial activity against Streptococcus mutans. So after confirming that the isolated compound has antibacterial through in silico approach and non-toxic, and it is very least, then we went for formulation of dental varnish. We used the theobromine nanoparticles as a main ingredient for remineralizing, and we added agarose for as an basically as for a polymeric base, and benzoin was added as a binding agent, so that we wanted to increase adherence rate to the varnish of the of the adherence of the varnish to the tooth surface, and we wanted a prolonged drug release. So we added the binding, and ethanol was added to as an solvent. In this formulation, our focus was mainly to have a natural ingredients. So we used all the three above: theobromine, agarose, benzoin. All were natural except ethanol, so that the formulated varnish is safe and without any toxicity or adverse effect. We can use safely in case of children also. So after formulation, then we went for characterization. So initially there was a color change. Immediately after preparation of the varnish, it was white in color. After 24 hours, there was a change in the color of the developed varnish. You can see here, you can see that the developed varnish was yellow in color. So we are characterized for physical, mechanical, rheological, and chemical properties. So on visual examination, showed that the developed varnish was smooth, homogeneous. It was homogeneous to feel with absence of lumps and grittiness. Whereas on microscopic evaluation under dark field and phase contrast microscope showed that the particles were uniformly distributed on the film matrix. And the film matrix, it was at an intimate contact with the surface it was applied. So SEM analysis also showed a uniform, homogeneous with intimate contact to the tooth surface applied. And atomic force microscopic study showed that the surface was smooth. Even it also showed it as a surface as a smooth, which is resistant against friction and wear. Next, we went for pH evaluation. The pH was about 6.9, and which was alkaline, and which was assessed with using a digital pH meter. So next we wanted to assess the drying time and casting time. We used both compressed air and even the natural drying. So using compressed air, the drying time was just 2 minutes. Whereas without compressed air, that is natural drying, without compressed air, so it was 20 minutes. So it was very good, like 2 minutes drying time, which is very apt for a dental application. Next, we assessed for the integrity of the film also assessed. The integrity of the film was lost while brushing, whereas the integrity of the film was maintained without any brushing. So this was also very good for us. And gel time of the formulation was 9 minutes, and whereas the gel temperature initially was 32 degrees centigrade and final gel temperature was 29 degrees, which was assessed using a test tube inversion method. So, and we assessed for the spreadability of the formulation also, where the spreadability was about 4.6 centimeter. And the extrudability was very good. It was near about 89% of the formulation was extruding from the pressing from the test tube. And the formulation had a very good water resistant capacity and exhibited a good mucoadhesive property also. And the viscosity value showed that the formulation was not too thin or not too thick. Which was good for oral application. Now moving on to the in vitro drug release. The formulation showed that the developed varnish as a sustained drug release of the from 0 to 4 hours from the polymeric matrix. So which we wanted this finding in our study. So we could achieve this sustained drug release. So moving on to the biocompatibility, we wanted to know whether it is biocompatible because we are dealing with the patients. We wanted to apply inside the patient mouth. So we also assessed for the biocompatibility. The biocompatibility results showed that the developed varnish is safe and can be used clinically since at different dilutions of 2.5%, 5%, 10%, 25%, nearly 90 to 98% of the cells were viable. This suggested that the developed varnish is safe and non-toxic and can be used in the patients. So then next we assessed for the antibacterial activity of the developed varnish. So to assess the antibacterial activity of the developed varnish, we used agar well diffusion method. The results showed that the developed varnish had an antibacterial activity with both Streptococcus mutans and Lactobacillus. These are the main key microorganisms that is necessary for the dental caries. So we selected these microorganisms. But the antibacterial activity of the developed varnish was less compared to the standard group. So where the standard group had a value of 12.75 millimeter zone of inhibition, whereas the developed varnish, it had a slightly lesser 10.5 millimeter zone of inhibition. You can see in the picture down F1. F1 is a developed varnish, S is the standard. So there is a good antibacterial activity, but less compared to that of a standard. So after this, we wanted to see the remineralization potential of the developed varnish. To assess the remineralization capacity of the developed varnish, we used spear cycling model. So we selected freshly extracted human first premolar tooth, and small enamel blocks were prepared by slicing the tooth, which were measuring about 4 millimeter in length, 2 millimeter in width, and 1.5 millimeter thickness. Then these enamel blocks were grouped into 3 groups, as I've shown in the picture. That is, group 1 is control, group 2 is standard, group 3 is novel dental varnish, which is denoted as F1 in the further. So initially, the baseline data of all these groups, like samples, the enamel samples were recorded for mineral loss. We assessed for the mineral loss, micro hardness, and mineral profile, like whether the calcium and phosphorus level is increased or not, that we saw, and even the surface morphology changes were there. So the baseline data means we didn't do any treatment, just like without any treatment, just we recorded the values. So the mineral loss was assessed using the Diagnodent pen, and whereas the surface micro hardness was assessed using both Vickers micro hardness tester and NanoInder tester. For mineral profile, that is calcium and phosphorus level, we used SEM EDEX analysis. For surface, just to see the surface morphology, we used a SEM analysis. After recording the baseline data, then we went for a demineralization of the enamel blocks. Means demineralization means we are going to create an artificial lesion on these selected enamel blocks. So how we will achieve this demineralization means we are going to treat this enamel blocks using demineralization solution for 7 days. Okay. After 7 days, you can see a white frosty appearance on the enamel surface. Once this white frosty appearance is formed, it indicates that initial enamel caries is formed, and which is nothing but it is also called as a white spot lesion. So after demineralization or after achieving the artificial carious lesion, again the basic readings is taken, that is for mineral loss, micro hardness, and surface morphology. After demineralization, the samples were subjected for remineralization. Okay, so using a peer cycling model for 28 days, using, as mentioned above, the 3 different varnish group. So after 28 days, again you are going to record for the basic data, mineral loss, micro hardness, and mineral profile. So moving on to the results. So the results showed that there was no significant difference between the groups at baseline and after demineralization. But after remineralization, there was a significant difference in all the groups. So the blue is denoted as baseline, the red one is demineralization, green one is remineralization. You can see between the groups, 3 groups, there is no difference in the baseline data and demineralization, but there is a difference after remineralization, but no change between the demineralization and remineralization in the control group. But in the standard and the this one developed varnish group, you can see there is a drastic change in the value. So first, assessment of the mineral content using the diagnodent pen. So showed that in case of a developed varnish group, there was increase in the mineral content after remineralization using the developed varnish when compared to the standard. You can see the value is 5. Lesser value means more mineral content is there. So compared to the standard, it is slightly more. It is 5. So it shows that there is a deposition of mineral. Coming to the surface microhardness assessment using Vickers microhardness test. So the results of the Vickers microhardness test also showed there is an increased microhardness after remineralization in developed varnish group. So you can see after remineralizing, there is the value has increased from 260 to 285. And on comparing between the standard and the developed group, you can see in the developed varnish group, you can see slightly more in the values, 285 to here in standard, it is just 284. So coming to again the surface microhardness assessment, but using with a depth sensing indentation tester. So the depth indentation result also showed increase in the surface microhardness, and this elastic modulus also was increased in the developed varnish group after remineralization, and it was more compared to that of a standard. You can see the standard is just 62, whereas in case of a fluoride the developed varnish, it is 65. So it is one of the good finding in the present study. Coming to the mineral profile using SEM EDEX. The mineral profile using EDEX showed calcium and phosphorus level was increased after remineralizing using developed varnish group, and it was slightly more compared to that of a standard. So that is another one good finding. So moving on to the surface topography using SEM analysis. So you can see the changes at baseline, at demineralized samples and remineralized. So the images at baseline, that is without any treatment, the normal enamel blocks showed smooth surface without any much changes. After demineralization, that is after creating an artificial carious lesion, you can see lot of porosities on the surface. So between the groups, there was not much differences. But after demineralization in the SEM analysis, you can see lot of changes. So you can see in the standard and the developed varnish group, you can see the changes. But in the control group, there was no change of, in demineralization and remineralization procedure. So The surface morphology after remineline in developed varnish group showed complete reduced porosity with shallow depressions with rounded margins. You can see the rounded margins, and there was a complete fusion of inter-rod spaces. That is another good finding, and this suggests that the developed varnish has got a remineralization potential. Even in the standard group also, you can see there was a reduced porosity was seen, and the surface showed a honeycomb appearance, and there was a fusion of inter-rod spaces was there. With slight, you can see in the image, you can see small globules deposition on the surface. So this shows that the developed varnish is equally effective in remineralizing the demineralized enamel surface in comparison to the standard 5% sodium fluoride varnish. So hence the developed varnish can be used in preventing the early white spot lesion which contains the theobromine nanoparticles. But you need further clinical trials to evaluate its long-term effect. There is a lot of future scope for the study in this thing. We can do a lot of in vitro and in vivo studies focusing on enamel acid dissolution, crystal size, and crystallinity of the tooth also can be assessed. And we can study what is the mechanism of action of theobromine based dental varnish on mineral deposit and how the crystal growth takes place can be investigated. So thank you. Thanks for giving me an opportunity to share my research work in this platform.
Thank you, Dr. Pushpa. Excellent your presentation, ma'am. Very clear, and the confidence of your presentation is amazing, ma'am.
Thank you, sir.
Ma'am, I just want to asking you that you use some chemicals like 5% sodium fluoride.
Yes, sir.
Yeah.
That is commercial. Yes, sir.
Is it a possibility, any possibility that we can replace any other chemical, is mineral, that we can get the same result?
Sir, actually, yes, sir. Actually, the 5% sodium fluoride varnish, what is that? It is commercially available. So since it has drawbacks, as I mentioned, few things, I have formulated this varnish with a better remineralizing. That is a theobromine. The study shows that the theobromine has got more remineralizing potential. Means it has got 7 times more than that of the synthetic sodium fluoride varnish. So that is the main intention. And I wanted to use a natural one only, natural, which is isolated from the natural product itself, so that because when we put it into the patient mouth, they shouldn't complain of any toxicity like irritation, and it should be safe for the patient, because we are presently we are more towards the synthetic products, and even though we know that it has a lot of side effects, still because we want a good effects like prevention, all that one, we are into that synthetic. So we want to move towards a natural. There are so many other products also, sir. There are like they have done with the propolis also, which has got a remineralizing propolis varnish. So this is an alternative. Theobromine is an alternative for sodium fluoride. I've compared between the standard, that is a sodium fluoride varnish, and whatever I have developed, that is a theobromine varnish.
Yeah, fantastic explanations. And can we move to slide 23, ma'am?
So you can see my
yes, ma'am. So there's 3 types of then the examples that in the standard group we can see that different in a porosity, is it?
Yes, sir. Yes, sir.
The remineralized sample is quite improvement.
Yeah. Yes, sir.
Yeah. So fantastic, ma'am. Fantastic. Your research. Good luck and all the best, ma'am. And thanks for your support and join this conference. And good luck, ma'am.
Thank you, sir. Thank you very much.
And now I'm open to our other participant, other speakers. Do you have any questions or anything you want to discuss with our Professor Puspa regarding a topic today? Anyone?
Ma'am, it was a very informative presentation, ma'am. Thanks a lot for the presentation, ma'am.
Thank you.
Thank you, Dr. Bhargavi. And okay, ma'am.
Okay,
So we end our session, morning session, until yours last presentation. Then we will start at 2 p.m. Malaysian time, 1 hour from now. 1 hour from now. We have all 1 and all 2, all the speakers and all the eminent speakers from European country. They will join and will share their research at 2 p.m. Malaysian time, 1 hour from now. Thank you so much.
Thank
See
you,
then.
sir.
Thank you, Dr. Nidhi. Catch you at,
sir.
yeah. Catch you later, man.
Okay, thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.